Good morning. My name is Jamie Barnett. I'm the chief of the FCC's Public Safety and Homeland Security Bureau. We appreciate you taking this time to be with us today to talk about how to leverage multiple technologies to deliver emergency alerts. And we're excited about this and the possibilities and are eager to hear from you about these issues. I'm delighted that my friend Damon Penn, Assistant Administrator of the FEMA, the Federal Emergency Management Agency, is here, and that FEMA is co-hosting this event. I'd like to thank them and the other federal partners, the National Oceanic and Atmospheric Administration, and the Department of Homeland Security Science and Technology Directorate. We're excited about the partnership and the collaboration that is developed among our agencies, and we're looking forward to working together on these challenging and crucial public safety communications issues. In addition, I'd like to thank our panelists, all of them, for taking the time out of their busy schedules to share their expertise on the important questions that will be discussed at today's workshop. I'd also like to recognize and thank my own folks, Lisa Folks, my Deputy Bureau Chief responsible for emergency alerting issues here at the FCC, Tom Beers, Greg Cook, and Jeff Goldthorpe for their work on emergency alerting issues, and Ann Buckingham, Antoine Johnson, and Wade Whitmer for their work on emergency issues at FEMA. I'd also like to thank Deborah Klein, who I think is over in the corner with Susan McLean, Rob Kinney, and DeAndrea Wilson for their work on planning these workshops. It really takes a lot to pull these together. Today's workshop is important. It is absolutely critical that members of the public have access to timely and accurate emergency alerts and warnings about impending disasters and other emergencies. One of our top priorities at the FCC has been and continues to be ensuring that all Americans have the capability to receive timely and accurate alerts, warnings, and critical information regarding emergencies, irrespective of the communication technologies that they use or have at hand. The American people rely on a multitude of communication technologies in their daily lives, and increasingly are relying on IP and other broadband technologies. A comprehensive alerting system that utilizes multiple communication technologies, including broadband technologies, will have the ability to reach more people, including those who are on the go, within a short period of time. For example, in the event of a hurricane, alerts could be aired over broadcast, cable, satellite, and other media outlets, sent to wireless and wireline phones within the affected area, posted on internet feeds and websites, and issued through any other communications outlet serving the affected area. Today's discussion will focus on how we get there. We hope that our panel discussions will touch on the following topics: the status of the Integrated Public Alert and Warning System, IPAWS, including Next Generation EAS and CMAS. What changes to the FCC's EAS rules are necessary in a CAP-based world, how we can leverage broadband technologies and the internet to distribute timely and accurate emergency alerts, how we can ensure that when a comprehensive broadband-based alerting system is deployed, state, tribal, territorial, and local government officials can and will want to use it, and finally, how do we ensure that all Americans can receive emergency alerts over this comprehensive broadband alerting systems, regardless of their capabilities or the capabilities of their technology. Again, thank you for taking the time to be with us today, either in person, and I would also mention this is a nice turnout here, but we also have many people attending over the web, and we appreciate their virtual presence as well. We appreciate your interest in ensuring that Americans have this capability to receive alerts over multiple technologies. And now I'd like to turn over the podium to my friend Damon Penn, who, as I mentioned, is Assistant Administrator of FEMA National Continuity Programs. So Damon, we welcome you here.
Well, thank you, Jamie, and thanks to you and Lisa and your entire staff and the FCC for putting this together for us and for being such great partners throughout. A real pleasure to be here, and most of all, I want to thank all of you for being here and for your participation, especially with all of the heated email that has been flowing back and forth up to this point. I think we'll have a great day today, and we'll be able to discuss a lot of the issues that are on your minds and move forward with our work at hand. And as all of you know, America's most valued commodity is its citizens. And as public servants, we have taken an oath to support and defend them and our way of life. And ensuring they receive alerts and warnings by all possible means is a task that all of us see as being as important as defending against terrorist attacks. It's one of the services we are expected to provide 100% of the time to 100% of the population. And the efforts that we take here today will help ensure that we can perform this task. As some of you know, FEMA's not always understood the importance of communicating alerts and warnings by multiple means, and how critical leveraging existing technology that the state, local, and tribal governments already possess is to the process. I can assure you that the administrator and I get it. And we understand the importance of that inclusion, and we are committed to developing solutions for the evolving needs of our citizens. To restate the obvious, as you all know, we no longer live in a society where we can reach our population by a single means. We have families that continue to receive the bulk of their information from radio and television, but living right next door to them, we have a family that doesn't own a television. They spend their time on the internet. Next on the street, there's a family that is consumed by social media, and their neighborhood relies on tribal leadership for most of their outside interaction. We've also got a large special needs community that we have to care for, and we also have the challenge of linguistics to overcome as well. So all of these together really make up our problem set and make up what our solution needs to be. So to meet these needs, emergency alerts and warnings are kind of taking a page out of the business model that our partners use. And I like to discuss it as being more of a applications-based approach versus a requirements-based. And I'll use BlackBerry and iPhones as an example of the difference and why the approach is so significant. If you look at a BlackBerry as an example, and please don't assume that I'm endorsing any products here, but if you look at a BlackBerry, what do you have? You've got a screen and you've got a keyboard. And you got that because we had a requirement or society had a requirement to develop a way to do internet on the move. So the people that developed the BlackBerry then did all the research and development to come up with a thing that did just that. So now you have a piece of equipment that has a screen and a keyboard, and it does email very well. The difference is with an application-based and the iPhone, then with the iPhone you get what? You get a touch screen. And if you need a keyboard, it's built into the application. And if you need a thumb wheel, it's built into the application. And what that has opened up in the business model is the ability to do an entirely different set of tasks that you never thought you needed. So, and somebody else pays for it for you and develops it and asks if they can bring that over and put that on your equipment. Now, what a novel idea. So that's what we're trying to do. So all of those things that my wife uses, like the little grocery store thing that says that you're a member of this club, or the bar reader, and all those other things that, for the life of me, I can't think why people would want, were all developed by somebody else at somebody else's expense and brought into the whole world of applications-based technology. We have those same things going on with alerts and warnings throughout. I spent the last 2 days in New York City. They have just a wealth of products and a wealth of information and knowledge that we can leverage and put into iPaws and share with the rest of the country and the rest of our citizens. Other states have led that approach as well. So leveraging that potential and working in an applications-based world is really why we're here today. And as Jamie said, discussing changes in iPaws, CMAS, and EAS, and recommending rules to the FCC on how to exploit broadband technology fully is critical. And our nation counts on us to do that, and I think today is a great step moving forward towards it. So thank you very much again for coming.
Turn over to Antoine.
Oh, I'm sorry, I was supposed to.
That's all right, go ahead.
I get so excited about this stuff, I forget. Yeah, I'd like to introduce Antoine Johnson. Antoine Johnson is the iPaws program manager, and he and his team are the ones that do the hard work. I'm the pretty face of this organization, and I know if I'm the pretty face, we got a lot of challenges. But fortunately, he knows a lot more about ones and zeros than I know about about delivering messages. So, Antoine, if you would introduce the panel, we'll get on to the work of the day.
Thank you, Mr. Penn. I think Mr. Penn, as well as Admiral Barnett, have really set the stage for what it is we're going to be discussing on this morning as part of this panel. Our panel is entitled The Path to Next Generation Alerting. We will be focusing on public alerts and warnings, discussing EAS and the commercial mobile alert system, as well as its integration into the integrated public alert and warning system being developed by FEMA in partnership with our federal partners and our private sector partners. We will also touch upon some of the decisions that are right on the horizon here with regards to Common Alerting Protocol and its adoption, as well as the Alaska exercise that was conducted back in January of this year, and a little about the national exercise or test that is being planned for 2011. Just to cover a little bit of history, most of you assembled in the room would know that the system that we're dealing with today to provide alert and warning to our U.S. citizens was primarily founded in 1951 during the Conrad program during the Truman administration. That evolved in 1963 to the Emergency Broadcast System, and in 1997 through FCC ruling to the Emergency Alert System. In 2006, there was an executive order that was published by then President George Bush, which tasked the federal government and primarily DHS and FEMA with developing the next generation alert and warning capability for the nation. And I'd just like to draw kind of the primary mandate from that particular executive order and just bring that to your attention. And it's really the guiding document, I guess the authoritative document that we refer to when it comes to the work that we've been assigned to do. And in the executive order, it states that it is U.S. policy to have an effective, reliable, integrated, flexible, and comprehensive system to alert and warn the American people in situations of war, terrorist attack, natural disaster, or other hazards to public safety and well-being. Pretty much sums up the entirety of what it is that we are attempting to do with regards to developing next generation alert and warning capabilities for the nation. Now I'd like to move on and introduce this august panel that we have assembled here on this morning. To my left is Mr. Henry Black. Henry, commonly referred to as Hank, is the Associate Chief of the Policy Division. Oh, I'm sorry. Started reading from the wrong bio.
2 pages in.
Yes.
I'll take the pay grade up.
Thanks so much. So Mr. Black is the Communications Branch and Technical Services lead with the Maryland Emergency Management Agency. In this role, Mr. Black has worked in emergency communications with local and state governments for the last 24 years. His current role is manager of the Communications Branch of the Maryland Emergency Management Agency. He advises MEMA, as it's being referred to, and other state agencies on matters affecting statewide emergency communications, including continuity of operations and interoperability for first response and disaster operations. Mr. Black is a technical advisor to the Maryland State Emergency Communications Committee. He also serves as the emergency management representative to the Public Safety Communications Review Committee for Region 20, which consists of Northern Virginia and Maryland. And he is a member of that same technical committee. He is a state representative to the Federal Interoperability Work Group of Shares for the high-frequency radio program of the National Communications System, and he also serves as the Emergency Management Maryland Point of Contact for the National Communications System programs for government emergency telecommunications services. So if you would, please join me in welcoming Mr. Henry Black to the panel.
Thank you.
So good to have you. Next to Mr. Henry Black is Mr. Greg Cook, who's the Associate Chief of the Policy Division within the Public Safety and Homeland Security Bureau here at the Federal Communications Commission. In his current position, Mr. Cook focuses on emergency alerting issues and leads the Bureau's team working with the White House, FEMA, NOAA, the broadcast community, and others to conduct a nationwide test of the emergency alert system. He has served as a senior legal counsel on the Bureau's Communication Systems Analysis Division, where he has co-led the Commission's Cybersecurity Working Group, acted as lead attorney on the FCC response to the National Security Council and Homeland Security Council's 60-day interagency cybersecurity review, and provided legal advice on implementation of Warning and Alert Response Network, the ACT proceedings. Greg joined the Commission in 1995 as an attorney advisor in the Common Carrier Bureau's Tariff Division. He received his JD from Fordham University School of Law and also has a degree from Boston University. Greg, thank you so much for being here, and please join me in welcoming Greg to the panel. Next, we have Mr. Steve Johnson, who is the president of Johnson Telecom and a consultant to NCTA. Steve is the owner-operator of Johnson Telecom, which is a technical consulting company in the cable and telecommunications field. His 34 years in cable television includes stints with United Cable, Cotton Associates, and a number of others. While he was employed with Time Warner Cable, he was the company's representative to Cable Labs' Open Cable Initiative and oversaw FCC technical compliance, among other standards-related responsibilities. Mr. Johnson has been very active in standards work with the Society of Cable Telecommunications Engineers, Consumer Electronics Association, and he also served as a member of the Federal Communications Commission's Technical Advisory Group on Emergency Alert Systems. He is also a senior member and was the fourth SCTE member to be certified in the Broadband Communications Engineer Program. And so he will probably have a great deal of interest in the panel that follows this one. He also writes a quarterly column on technical regulatory issues for Broadband Library and has written numerous papers and articles in the cable engineering field. Please join me in welcoming Steve Johnson to the panel. Next to him is Mr. Brian Joseph. Brian is the Director of Regulatory Affairs with CTIA, commonly referred to as the Wireless Association, which is an international trade association located right here in Washington, D.C. Since joining CTIA in 2006, Mr. Joseph has worked on a wide range of issues involving spectrum, regulatory mandates, tower siting, public safety, and homeland security. Prior to joining CTIA, he worked as an attorney for Cole, Raywood, and Braverman, where he advised clients on cable, wireless, and common carrier issues, including licensing, compliance, and policy matters. He received his BA in International Relations from the University of Pennsylvania and his JD from Catholic University of America. Please join me in welcoming Brian to the panel. Next to Brian is Mr. Mark Paese, who is the Director of the Office of Operational Systems with the National Oceanic and Atmospheric Administration, National Weather Service. Mark is responsible for the day-to-day management of the National Weather Service operational systems and has 28 years of experience in all facets of weather, communications, and aviation, including 12 years in private industry. Prior to his stint at NOAA, Mark held a position in the international consulting firm of Booz Allen and Hamilton, and prior to that was a system engineer with Westinghouse Electric Corporation. Mark has served as the co-executive director of the White House Task Force on Effective Warnings, and his efforts resulted in the President signing the executive order to which I just referred to, Executive Order 13407 on public alert and warning systems. Mark also served on the FCC's Commercial Mobile Service Alert Advisory Committee, which was charged with examining existing and planned disaster warning systems and developing recommendations to ensure effective all-hazards alert and warning systems. Mark is a recipient of the 2007 Presidential Rank Award, 4 Department of Commerce Bronze Medal Awards, and a NOAA Administrations Award. So he's well decorated. Please join me in welcoming Mark Paese to the panel. Next to Mark is Mr. Kelly Williams. And Kelly is the Senior Director of Engineering and Technology Policy with the National Association of Broadcasters. Mark joined NAB in 1989 and has worked on numerous issues such as radio frequency exposure, emergency alert system, the V-chip effort, as well as a number of other efforts over at the National Association of Broadcasters. He has represented broadcasters' interest on various industry technology standards committees and in cross-industry forums, including the President's Council on Y2K Conversion, the FCC's Commercial Mobile Alert Advisory Committee, and Media Security and Reliability Council. He currently focuses on spectrum issues and advises NAB legal and government relations staff on technology and spectrum management matters. He also serves on the FCC's Communications Security, Reliability, and Interoperability Council. Mr. Williams has a BS in Electrical Engineering from Howard University. Please join me in welcoming Kelly Williams to the panel.
Thank you. Very great.
And last but not least is Mr. Wade Whitmer, who is the Deputy Director at DHS FEMA for the Integrated Public Alert and Warning System. Wade began working at FEMA in January of 2009, and prior to his position here at in FEMA, he was employed with the Defense Information Systems Agency for 9 years, serving as the Portfolio Manager for Mobile Communications in the Presidential Communications Upgrade Program Management Office, and finally as the White House Communications Agency Deputy Director for Enterprise Architecture, Strategic Planning, and Systems Engineering. He has over 19 years of experience in government systems engineering and government program acquisition. Wade is a graduate of Penn State University with a BS in Electrical Engineering. Please join me in welcoming Mr. Wade Whitmer to the panel. We're going to begin by having each of the panel members just provide brief opening remarks just to share a little with us about their perspective and where they come from and their interest in alert and warning for the nation. We'll start first with Henry.
Well, thank you very much, and thank you to the FCC and FEMA for inviting me to participate on this panel. Let me state that the views expressed by me today are based on my professional experience in emergency management over the last 24 years and don't necessarily represent the views of my employer or the Maryland State Emergency Communications Committee. I have been involved in communicating messages of one type or another in one form or another, at one level or another, at one level or another of urgency for various governmental entities and non-governmental entities for the last 20 years. In my present position, I serve as a communications officer and also as the manager for the telecommunications section of the agency. As part of my duties, I deal with the national security emergency preparedness programs at least 3 levels with federal agencies, to include the Maryland State Operations Plan, Emergency Support Function number 2, Communications, and part of the ESF2 includes the emergency alert system to alert the public in Maryland. I currently serve, starting in 2003, as the technical advisor to the Maryland State Emergency Communications Committee, while serving as chairman previously of the Communications Committee of the Governor's Emergency Management Advisory Committee, the GMAC. In 1994 to 2002, I promoted trying to find solutions to provide an interoperable, inexpensive, robust, reliable, secure solution or solutions to the issue of connecting emergency management operations centers to the broadcasters. And in order to issue the EAS messages to our listening public and viewing public, and we did find a single solution. And funding needed to be secured for this. In 2003, we went before the Board of Public Works, got their blessing, and were able to implement, starting in 2004, the solution that was found and involved a protocol called TCP/IP in the internet. It also used satellites and the public switch connectivity. All technical concerns that we had, either by the broadcasters or by the emergency operations folks, were mitigated. We were able to cover 90% of the potential viewing and listening public at the time in Maryland, directly covered by this satellite-based delivery system for ES messages. All local primary stations and state relay stations were outfitted with the equipment, and within 2 years we added the capability to the application to provide simple messaging service, cellular, and email capability to the delivery of these messages. Once the FCC announced the coming of the Common Alert Protocol, the network and the applications that we secured included the CAP as a method of origination and delivery. So we are technology ready for the changes once the FCC publishes in the Federal Register the FEMA adoption of the CAP protocol. And however, we still have challenges ahead in the area of training for the originators of the alerts and the public who receive these messages. Amber Alerts in Maryland currently is a success story, but that's just one type of the alerts. There are more, and more funding is needed so that all the alert types are understood by the public properly and concisely, issued by trained, authorized originators. And we still have a lot of work to do in targeted communities of multilingual backgrounds and ethnic cultures. And one of the, I guess, desires I'd like to see is that the document that was issued in 2002 in developing a unified all-hazard public warning system, which was issued by the Partnership for Public Warning, have that report updated to where we are today, especially when we talk about the social aspects of alert and warning. And of course, the National Academy of Sciences had a panel in which my director participated back in April, dealing with the social aspects of these warnings in terms of their understanding, the use of the terminology, and the terms that we have, so that when one alert goes out, it's understood by all on what the proactive actions that they need to take to protect their lives and their belongings. So that's kind of where I'm coming from for the perspective today, and sharing my thoughts, views, and observations over the years that we've been doing public warning in Maryland. And the new technology gives us added venues for us to deliver these messages, and it presents unique problems, especially when you've got to get concise information in 90 characters in order to meet the cellular mobile alert system requirements. So we're going to work with them, and we're going to train our originators to have effective messages. Thank you very much.
Thank you, Hank. We'll now have some brief remarks by Mr. Greg Cook.
Thank you, Antoine. And thank you, Admiral Barnett and Mr. Penn, and I'm very excited about being here today. As Admiral Barnett and Mr. Penn and Antoine pointed out, the overarching policy of the FCC and its federal and state and industry partners has been to bring accurate, timely, state-of-the-art alerts to the American public. And the job that we at the FCC have had in that context has been multiple. It has been to facilitate the entry of these new technologies into the public and alert and warning sphere, to assure a reasonable transition from the current system to these new technologies, and that which affects us most, at least me most here today, is to make sure that the current system works. And in that regard, we have, at the FCC, have done a number of rulemakings over the last 7 years to affect this. Back in 2004, we initiated a rulemaking for the emergency alert system that resulted in an order that brought digital media into compliance with our Part 11 rules. So thus, the whole digital TV transition could be effected in such a way that for the purposes of alert and warning and the EAS would be transparent to the American public. Similarly, whether it was satellite radio such as Sirius and XM or cable television, moving into the digital age, there were no blocks in terms of the delivery of EAS. Also in that document, we anticipated next generation networks, anticipated the advent of the Common Alerting Protocol, and initiated a whole set of questions on how we could best affect a next generation network, a next generation alert and warning using the Common Alerting Protocol. During the pendency of this rulemaking, of course, Congress passed the WARN Act, and we then developed, in context with our federal and state partners, the the commercial mobile alert system. And I just want to devote, I don't want to steal anybody's thunder, but I think this is a great example of how groups like this, how government, industry, state, special interest partners can work together to effect a really top flight, top technologically robust and effective system. We had the Commercial Mobile Service Alert Advisory Committee that was mandated by Congress that turned out to be a highly collegial and effective group. Along with Jeff Goldthorpe, I worked in the project management group of that, coordinating the various industry groups to come up with the technical protocols for the CMS. And right now we are, as will be discussed later, on a track to really bring this first generation, and 90 characters, with all due respect, is strictly anticipated as a first generation commercial mobile alert. Currently, we are looking at a number of things. We're looking at the introduction of CAP. We have issued a public notice that has requested comment on what changes to our Part 11 rules are going to be necessary once the commercial alerting protocol comes into place, which hopefully will be at some point before, in the next few months, as we've been discussing with FEMA. And that will bring a number of changes to play in the parts of the states. It will begin to mandate carriage of governor alerts along the EAS system. It will also open up a wide spectrum of technical possibilities for the delivery of alerts, for the delivery of one single message over multiple media to all the people at the same time, whether they are listening to the radio, whether they're on the internet, whether they're driving down the road looking at a highway sign. It has tremendous potential to be a very effective and efficient way of delivering a tremendous amount of information to the American public. But while we're doing this, we cannot lose sight of what has been and will continue to be the backbone of any alert and warning system, which is traditional alert and warning system. And it's no joke that, as Antoine pointed out, that this was a Truman Cold War era architecture. It is designed and developed, as I'm sure my colleagues at FEMA would agree, to work when nothing else does, to be the last resort of alert and warning that can deliver a simple message to as many people as possible over a robust architecture. And so to ensure that works, we have issued a rulemaking, a record for which is now closed, that will initiate the first ever end-to-end national test of the emergency alert system. And we're very excited about this. We're very excited about working with FEMA, working with the White House, working with the manufacturers, working with our industry partners to actually bring to the American public the proof that we can all work together to deliver a very complicated yet effective alert to the American public. And I think that the test that we had a few months ago in Alaska shows that this kind of partnership can work, that we can work out the technical bugs, that we can work together, we can do the proper outreach, and we can really bring something of tremendous value to the American public. So I look forward to this panel this morning. Thank you very much.
Thank you, Brad. Our next set of comments and opening remarks will come from Mr. Steve Johnson. Steve, the floor is yours.
Okay. Thank you, Antoine. I'm very pleased to be here on behalf of the National Cable and Telecommunications Association. Cable television has been kind of one of the latecomers to the EAS program. We weren't involved in it as long as the broadcasters were, but for many years, even prior to EAS, we had requirements in state and local franchises to provide emergency alerting capability to allow local governments the option to override the cable channels in case of emergency. So we do have some long years of experience in emergency alerting with lowercase letters rather than the capital EAS. In 1990, the FCC started its process of revamping the old EBS system, and then they asked cable operators to get involved through discussions with the Society of Cable Telecommunications Engineers. During that time, there were meetings around the country getting feedback from different cable operators and different participants, and various methods were tested to see what might be workable, and eventually a workable solution was arrived at. The FCC issued a notice of proposed rulemaking, and Part 11 was the outcome of that, and as part of that, the EBS system was renamed the EAS system. The broadcast was substituted for alert, indicating that there were other participants in there now, such as the cable television industry. And cable television operators began participating in EAS in 1997. It's evolved over the years. During the early 90s, we had no digital television to deal with, so we had to evolve the system as we progressed. We're looking forward to the evolution and the introduction of CAP. It will allow us to have more detail on our emergency messaging. It is IP-based, so it will be more robust. And as part of that, there will be mandatory governor alerts that will be carried. And there will be new equipment required or modifications to the existing equipment. And one of the provisions is 180 days to implementation after FEMA approves the standard, according to FCC Part 11 rules. The FCC issued the public notice, as Greg mentioned, on the review of the emergency alert system. And almost all of the commenters agreed that the 180 days was insufficient. They're talking about taking a product, a brand new product, going through the R&D phase, building up prototypes, testing, developing the product, getting it certified, getting it manufactured, selling the product, distributing it, sales, installing the product, getting it up and operational, and providing the training to the users for that product. And 180 days is thought to be way insufficient and needs to be extended. We need to better define the conversion or the translation from CAP protocol to the EAS protocol, so we'll have a smoother transition. There's a lot of open issues and questions about that. We need to define how the governor's alert will work. We need the details so that that gets well documented and everybody is playing from the same sheet. We need training for the operators and for the system, for the message originators, so that the originators originate messages that will be recognized by the receiving equipment, and it will flow seamlessly throughout the network. We had a situation, and one of the things we learned in Alaska was that the message was incorrectly encoded as far as the originating code. And a lot of the cable operators in the automated mode on their EAS equipment did not recognize that message because it was an invalid code and simply ignored it. So we need to prevent those types of accidents from happening. The national testing also showed the need for consistency on EAS and raised some issues about what should be used for location code, the originator code that should be used, and how the decoders react to an EAN message. One manufacturer ignores the location code while another manufacturer looks for a specific location code. We need to have some clarification on which way that should go. So I guess going forward, we have some immediate issues that we would like to see addressed in the cable industry. We would like to extend that 180-day window, see a definition of the CAP to EAS converter, define the procedures for the governor's alerts, establish training programs, and have a clarification of the national alerting procedures, including the testing on what we'll be doing from now on. The cable industry also has some challenges that we're delivering programming to television sets and other consumer devices. We're delivering programming to cable TV ready digital televisions with a cable card, with TV sets with set-top converters, and soon we'll be delivering TV via internet protocol to monitors and other devices that might not even contain a television tuner in them. So we have all these different platforms we need to support, and we're continually challenged on how we're going to do that, and we're continually working on that. And I welcome the discussion that I hope will come out of today's meeting, and thank you very much for the invitation.
Thank you so much, Steve. And a number of the issues that you have raised here are quite common to us in terms of the 180-day clock for compliance with FCC rules, as well as some of the training issues and the period of time that is required to get devices to market and to have folks trained up on those devices. And so I'm sure we will have a fairly lively discussion on those issues as we entertain questions from both the panel and those who are assembled here, as well as our internet participants who will be providing tweets as well. Thanks so much. Next is Mr. Brian Joseph. Brian, the floor is yours for your remarks.
Great, thanks, Antoine. Again, I want to extend my thanks to the FCC and to FEMA for holding this workshop today and for inviting me to participate. I'm here to talk about CMAS, and I'm going to focus my remarks on that. Picking up on Greg's mention of the effort underway, I think it's fair to say that CTIA and certainly our member companies supported the development and delivery of wireless emergency alerts to our nation's wireless subscribers right from the get-go. There was the genuine belief that this service will ultimately protect America and save lives. As Greg mentioned, the WARN Act was enacted back in 2006. It established a process for commercial wireless providers to voluntarily elect to transmit alerts to the public. And under the WARN Act, Congress devised a unique procedure to address the problem of emergency alerting by getting the participation of interested parties to work on the development and deployment of a commercial mobile alert service. I agree with Greg. I think Congress's plan is working as scripted, and to date, it's one of the great leading examples of a successful public-private partnership. Following the requirements of the WARN Act, the FCC established an advisory committee. There were more than 40 members on that committee representing, among others, federal, state, local, tribal governments, commercial providers, vendors, broadcasters, consumer groups, and other technical experts, including a number of people both on the panel, entities both on the panel and in the audience today. And through a one-year process, through its charge of developing recommendations for the technical requirements for wireless carriers to voluntarily transmit the emergency alerts, the advisory committee carefully considered all relevant issues to formulate what would be a workable operational plan for CMAS. And in April 2008, after the advisory committee delivered its recommendations, the Commission adopted the committee's recommendations regarding the technical elements, protocols, etc. I think from those in the audience and the discussion, many are familiar with the key aspects of that order, but certainly I think we'll have opportunity to address that in the question and answer session. But since the April order, two additional orders have been put out by the FCC, and a technical industry government working group has been working feverishly on the standards development process. April 2012 is the timeline for delivery of developing standards and deploying and testing the alerts. But the technical working group, most of its efforts to date have focused on industry, FEMA, and DHS, finalizing the C Gateway Interface technical specification and procedures for alert origination, and then beginning development and testing of equipment necessary for fulfilling FEMA's role as alert aggregator and gateway administrator. 2 points I want to make today. Again, I think the work on standardization efforts has been very good on both the industry and the government sides, and we're encouraged by that. I want to ensure that in standing up the version 1.0 of the CMAS, we make sure that we walk before we can run. As echoing Greg's comment, we want to make sure that the system works in the first iteration before we risk, getting sidetracked on implementing this as part of a other plan or focusing on evolution before we've even launched the first iteration of the CMAS. And then I also want to echo Hank's comments. We need to address the education elements for alert originators and for the public. State and local emergency operations centers need effective procedures in place to successfully initiate the CMAS process. I agree there's going to be a large education process and coordination needed. I think there's been the acknowledgement that that needs to happen both for the alert origination community and for the public. I'm certain that as carriers are communicating with their subscribers on upgrades and change-outs to CMAS capable handsets, there will be that part of the education process. So, those are, I think, some key issues that I hope we'll further explore. But I look forward to an in-depth discussion this morning. Thank you.
Thank you, Brian. And certainly all issues that we're well familiar with and should provide for a very fruitful discussion this morning. Next providing remarks will be Mr. Mark Paisi.
Good morning, Antoine. Thank you, and thank you, Admiral Barnett and Mr. Penn, for setting this up, and great turnout for everyone, and my esteemed colleagues for coordinating here. So the role of IPAWS and NOAA, what is our role? How do we fit into this? And it was mentioned earlier, NOAA is a federal partner, a full partner in this system. We, of course, take the lead from FEMA and DHS in the leadership role for IPAWS. It is indeed FCC, DHS, Science and Technology is involved in this, and certainly NOAA as an originator and disseminator of information. We are, as mentioned, we are developing a system of systems, standards-based, protocol-based, and there's not one solution. There are many solutions with multiple technologies. So as we move forward, we're going to build that together with the broadcasters, the cellular industry, cable, broadband, internet, social media, and of course the next group panel after us will discuss that in further. So as was mentioned, I do have an interest in the Integrated Public Alert and Warning System in the executive order, having had some history with that and some fingerprints on it, I guess. And certainly it is the foundation for us to move forward and to make that collaboration, develop those systems and technologies. So in order to do that, we need to have that partnership with the state and the locals, the broadcasters, the private sector, academia, the NGOs, so that we are able to develop standards and protocols as we move forward that are based on ways that equipment and handsets and other devices can be developed. So the role of NOAA as an originator, of course, many of you know approximately 85 to 90% of the emergency alerts are weather-related, so we understand the criticality of getting alerts and warnings out, and any modification to that system is critical that we keep the thing running as we move forward. Of course, what is highlighted, as was mentioned earlier, NOAA does have a communications infrastructure that we will leverage and move forward on. We have a dissemination system that is satellite-based. We have our NOAA Weather Radio system. We have worked collaboratively with our HasCollect system with FEMA, and of course our geo-targeting and alerting system to get those alerts and warnings down to the polygons, if you will. And alerts and warnings are important, and obviously was highlighted this past weekend with the deadly tornadoes in Ohio, in Illinois, and Michigan. Time-critical information is important. So we had fatalities, which are 7 too many, if I recall the number, in Ohio. A good news story is in Elmwood, Illinois, right 20 miles outside of Peoria. They had a plan. They got the information. They got out the alert and warning, the festival that was going on. They executed their plan. They took the people who were at the festival in the movie theater, got them to the basement. The before picture is people milling around in a movie theater. The after picture is the roof missing. So that is the key of, as we move forward, that we need to be able to protect lives and property as we enable a system of systems to get the alerts and warnings out. And certainly it's alerts and warnings, but it's also the crisis, if you will, what's going on in the Gulf today with deep water. NOAA has a hand and a major role in supporting that effort and getting the information to the fisheries closures of where they are for the fishermen, the mariners, and providing the support to our federal partners, the U.S. Coast Guard, DHS, so that we can get that information daily out to the public and to the people who need the information for their livelihood. So as we move forward, I believe we need a holistic approach in formulating the message, and as was mentioned, a social science aspect we need to look at of how we capture that message and how we best articulate it and get it out there, receiving the message and then taking necessary actions. So the origination process has to be paramount, that we look at validation, verification, authentication, and looking at a secure means to getting it there. And then also working with the federal, state, and local partners, academia, the private sector, subject matter experts, so that we can develop those protocols and standards so that the manufacturers and suppliers can develop the products we need to help protect lives and property. So we look forward to working, as we have in the past, together with our partners to continue to improve EAS and build an integrated public alert and warning system. And thank you.
Thanks so much, Mark. All very good points that I'm sure will be addressed during this session. And next to the mic will be Mr. Kelly Williams, who will provide brief remarks.
Good morning, everyone. Thank you, Jamie. Thank you, Damon, for putting this together. Thanks, everybody, for coming. Antoine asked us to say a little bit about our role in EAS. And anybody who's ever seen me in any panel say that I take culpability for some of this because I was the one who got the assignment to pen, excuse the use of the word, to pen the petition that started all of this back in 1991 that asked the FCC to review the EBS. But now I can say it's his fault because it's not my fault anymore alone. It's your fault too because you got the team effort, absolutely. So broadcasters have been a part of EAS from the very beginning. It really, the existing EAS really took place in the early 60s when President Kennedy wanted a system to address the people in time of emergency. While we talk about CONRAD as something that predated, it was the beginning, its purpose was different. Its purpose was to get radio stations off the air so that our enemies couldn't use radio stations for targeting location during times of war. That's a different purpose, really. So the modern EAS started with broadcasters. The president actually came to NAB and he said, gee, we'd like to seize all the radio stations. We went, well, let's not do it that way. How about if we volunteer to let you use them during time of emergency, and the rest is history. So we're really excited, and I personally am excited because I've been working on EBS and EAS since 1989. And it's really interesting. There's been more progress in the last year than there has been, I'd say, in the last 5 years in getting forward. And I commend the FCC and FEMA for working together to move things forward. Because from my personal opinion, things were kind of at a standstill for a while. And so we're really excited to see them, making progress. And yeah, there's a lot of moving parts here, but the parts are moving, and I think that's an important thing. So, interestingly, Steve stole most of my comments. I mean, it pretty much is a tick list in the order that I had them written down. So there are a few things moving forward. Now, I'll tell you, we're going to talk about them later, so I'm just going to run through them really quickly. From a broadcaster perspective, looking forward, there's not a lot of clarity on what we will have to, how many different sources we'll have to monitor if we continue in our same role. And I think we need some clarification, and this leads into the next issue, which is the 180-day clock. But sort of going forward, I see that at least three basic things that we've got to monitor in one way or the other. One is a federal system, IPAWS. Two is whatever a state system is to support the governor's message and so forth, and NWS. My understanding, and Mark, you can correct me if I'm wrong, I don't think you guys are moving away from SAME anytime in the near future. Yeah, right. So we still have to be able, like you mentioned, most alerts are weather alerts, so we still need to accommodate SAME messages. And for those of you who don't know what that is, there's a glossary in the back of the handouts. No, I'm kidding. There is no handout. So that's just a concern of ours. I think we like to see focused on as we go forward in really clarifying how that works and how what's commonly referred to as the daisy chain where you have stations monitoring stations and that sort of thing. This gets back to state plans, states that have really robust plans and well thought out plans. I happen to have been a former resident of Maryland, and I know that Maryland has had a great plan put together with Northern Virginia and D.C. for years, and I'm happy to know that, because I lived right on Tornado Alley, lived right off 95 in Prince George's County. But anyway, so how that's going to work and what we're going to monitor, and will the daisy chain stay or not stay, and things like that are really issues in the purview of the FCC that I think they need to clarify going forward as part of sort of restructuring the Part 11 rules. The 180-day clock, well, I think Steve just really, he hit all the issues right on the head. One thing that's really kind of top of mind for me, as I've talked to a number of manufacturers, it seems to be unclear what the role of type certification, for example, an EAS, a cap to EAS box, whether it needs to be certified, when could they apply, things like that. I mean, those are issues. Again, the commission needs to, it's not really a FEMA thing, but the commission needs to look at that and clarify that. But the 180-day clock, I think there was consensus that it is probably not enough time. And it is a personal opinion. I don't know that FEMA necessarily should be looking at sliding what they do, but rather the FCC should look at it and say, what's a realistic time period, or change the trigger. The announcement shouldn't be FEMA's adoption of CAP. The announcement should be when products are available, or when products get through type, if you decide products have to be type certified or type approved. I can't remember which they have to be under Part 11. But that needs to look at. Clearly 180 days is not, it's probably barely enough time to get the products to market. And then you got to see about getting them manufactured, sold. There are, what was the number, 30,000 EAS participants, something, 27,000, and 8 manufacturers. So I think that's a number. There may be some new people getting the business, but that's the order of magnitude. So I think you have to look at it from a reasonable standpoint. The governor's message, again, just clarify it. There are a number of things in the record. I think we all ask the same questions. What did you mean when you said? I don't think we can talk about it later, but the other issue. So I finished the list of things of which NCT and NAB agree. There's an issue of cable override, and that is where the mandate for cable stations to override all stations takes away, from our perspective, critical information from the audience. And you have a broadcaster who's giving detailed information, and a cable system that's in an automated mode puts up just a crawl and obliterates that information. So right now the rules require that. There is a provision to negotiate that, but there are some questions of whether or not the technology is capable, digital cable technology is capable of doing it in all cases. We maintain it is. NCTA says, well, no, it isn't really. It's complicated. But we think that the rules need to be modified to not require override of all channels, but to make an exception for broadcast stations that are providing emergency information. So that's my tick list. I'm sure other stuff will come up. Thank you very much.
Thanks so much, Kelly. And last but not least, yet again, is Mr. Wade Whitmer, who will provide brief opening remarks.
And I'd just like to start with some thank yous. I think looking around and seeing here in the room almost the entire community of interest for alert and warning represented, and to say that community has been very active over the last year and a half that I'm familiar with it, and I think that a lot of things have been accomplished, and that's attributable to the interest shown by the community being represented here today, and the importance that the community places on getting this getting this first block in place for the next generation and an integration of alert and warning. And that's very appreciated. So where are we? A little bit about IPAWS very quickly. Over the past year and a half, with efforts that got started way before that, the IPAWS specification for CAP was completed in the last 12 months. The CAP standard is on track to be done next month. An implementation guide to address some of these EAS and CAP compatibility, CAP to EAS translation issues. First draft is out. The CMAS spec to define the interface with the cellular industry is in place, and implementation plans and planning for that is rolling. The FCC has continued to actively work the regulatory environment and any changes that may be needed as we move forward. And of course, actively engaged with between FEMA and NOAA to begin integration of the capabilities that we want to have existing, that they have existing, and that we want to be able to leverage across all aspects of the alert and warning community. We have our initial aggregator infrastructure in final integration testing to be brought online in a FEMA data center in the next 2 months. That includes the beginnings of the gateway functionality to all pieces that may be able to push something to the public. I'd like to say that the shovel's in the ground for putting this next building block in place, the first building block in place to this new capability for alert and warning. And last, but I'd be remiss not to mention that planning is well underway, and as Mr. Cook mentioned, for a national exercise, not just a national exercise, but a national exercise program and a continuation of that on an annual basis that really is going to be a key piece, and we're looking to be a key piece in bringing awareness to not just the community that's represented in this room, but really to help push, to educate all aspects that we have out there on the importance of alerting to our society, and really to help continue this partnership piece amongst all sectors in the community, and really to make sure that the American public is on board and understands what we're doing. Thank you for being here.
Okay, thank you so much, Wade. I think that's a good lead-in for some of the questions to the panelists on this morning, and I think, Wade, you've done a great job in identifying some of the ongoing developments within the IPOS arena with regards to CAP being on the horizon, as well as some of the development efforts with the IPOS, or federal aggregator, being going into testing and initial kind of operating capability over the next 2 months, along with the CMAS component being up and available for testing in accordance with FEMA plans in February of 2012. But along with that, I just wanted to get a brief kind of reaction from the panel assembled here in terms of, Hank, from a state perspective, in terms of how those things align with state efforts, with the pending announcement of CAP, I think is anticipated in September of this year, along with some of the aggregation services that are being stood up by FEMA as part of the federal aggregator. So from a state perspective, how do those things align with ongoing efforts within the states?
That's a good question, Antoine, and it's one that each state has within their systems unique issues to deal with to make it work. And while I can't speak for the other states, it goes to an issue of how the alert message is originated, whether the state controls the origination of a local alert, or does the local group have the ability to originate directly without going through the state. And in Maryland, we allow the locals to originate all messages accordingly. And so our concern is how the aggregation gateway is going to work for us, and what is that going to do when you look at the overall design and you see this cloud that's sort of nebulous, and you're trying to determine, are you going to have a situation that is going to cause multiple alert triggers for the same event? And while we're cautioned that it's not anticipated, you know, we're still waiting to see how those designs where we put something out at the state level, it goes out through NOAA weather radio, and it goes directly in Maryland from the originator to the broadcaster, and the broadcaster has multiple inputs. We believe that the CAP protocol will eliminate any possibility of having duplicate message or multiple originations. Now, we've had people comment and say, well, what is wrong with having more than one message of the same message? And it goes to that social aspect where people will start tuning out. They'll see these as not being life-threatening. And again, it goes to some other issues where, yes, we still want to get non-life-threatening alert and warnings of different levels, and the CAP protocol allows that very, very well. The technology's there, the solutions are there, it's just the time that it takes, and our concern is understanding that process of where we are. Fortunately, both our state representative to the committee as well as our local representative for emergency managers is participating in the IPAWS working group. So we're keeping up with what's going on. We still have some concerns, but we haven't been able to truly formulate some specific questions to answer other than the education process and the training issues that we're going to see down the line. Mm-hmm. The technology doesn't scare us at all. We just want to know where we're going to get the money to buy the replacements, and then that we'll get into later.
Yeah, I was kind of wondering when the money issue was going to surface on this panel. We actually made it through all of the introductory remarks without talking about money. But certainly that's a concern for a number of the folks in our community, both on the private sector side, our broadcasters, as well as the state and locals who will, as a result of CAP adoption, be required to either purchase new devices or upgrade the ones that they have where those things can be upgraded or modified. Very, very relevant point, and certainly a concern that I'm sure as we go forward in partnership that we'll be able to figure this thing out in a manner that will be in the best interest of all of the parties involved. But from Brian, from a wireless perspective, one of the things with the adoption of CAP and other activities that are planned with the evolution of the next generation alert and warning capabilities for the nation, are there, you mentioned that the initial offering of CMAS was just that, the initial offering where 90-character messages would be delivered to cellular handsets and things of that nature. But are there areas that you feel we could better leverage from a wireless perspective to bring more effective alert and warning to American citizens?
I think that it's an excellent question, and in my remarks earlier about standing up version 1.0, absolutely hear everyone, and I'm sure there are the sentiments in the audience about the limitations of the 90-character message length. Again, emphasize that is the initial offering. By design, the CMAS process and the advisory committee was looking at standing up a system that would work, that would be reliable, that would be robust in a point-to-multi-point type of environment that would not suffer from latency, congestion, et cetera. And in that way, almost in the first iteration, be a bell ringer. Get the word out that there is an incident, and for people to consult other sources of information or to get to safety, and then assess next steps. The CAP, I think, plays an important role, and the federal gateway and the alert aggregator in streamlining the message and getting that information out. There is an eye toward the evolution of the CMAS. The advisory committee itself flagged a number of issues, forward-looking, enhanced geo-targeting, multiple languages, et cetera. Not to get ahead of the next panel, but I think in the discussions of future technologies, there will be certainly some relevance to evolution of air interfaces and enhanced capabilities along those lines. And third, you have in the WARN Act Section 604, which tasks DHS S&T with evaluating, ways to improve, enhance, basically evolve the alerting process. And I think that's something that industry will be on board with. We, are all moving toward that common goal. But as Wade mentioned, building blocks. I think we want to make sure that CMAS gets stood up is a operational, robust, functioning building block before taking it to those next levels.
Good. And just one follow-on question about on CMAS, the issue of CMAS. FEMA has made it known publicly that it intends to have the CMAS gateway up and available for testing with industry in February of 2011. In your opinion, do you feel industry will be prepared to move forward with the testing in February of 2011?
I do. I think even before the final gateway specification was adopted, the technical industry and government working group started their efforts on a testing specification. That is underway. That is moving forward, and not to put a definitive timeline on that. I think we will see that stood up next year in 2011 to begin that testing. So I think that is something that both sides are working very well toward accelerating.
And I can tell you that from a federal perspective, we certainly enjoy the collaboration and the partnership in going forward. And certainly, we could not do what we do in terms of the mandate that we've received with regards to alert and warning without that public-private partnership being as solid as it is. And so we really appreciate that. But Greg, just for FCC, there have been a number of comments on CFR 47 Part 11. And some of the apparent mandates there with regards to timelines and other compliance-related issues. Does the FCC anticipate additional rulemaking, or have you received? I don't know how much you can get into with regards to the 180-day clock or the concerns that are being expressed by both Kelly and Steve here at the table with regards to the 180-day clock and type certification of equipment for use in EAS. But if you could share any thoughts about that and, from an FCC perspective.
Well, clearly, I can't comment on what we might do with these comments, but we certainly anticipated that there would be a number of significant issues affecting our Part 11 rules that would come from the introduction of the Common Alerting Protocol. And that's why we issued the public notice that we did, that actually I think we got our initial comments just a couple of weeks ago, and the 17th of last month, and the replies will be coming in on Monday. And so, of course, we're already aware of the comments that have come in on their concerns about the 180-day clock, et cetera. I know from our perspective, this wasn't a figure that was picked out of the air. We realized that we've been working very closely with our partners and seeing what the work that's being done in OASIS and the development of CAP 1.1, and certainly have been meeting with encoder decoder manufacturers throughout and discussing issues concerning how one can operate the current legacy system using the same protocols and using CAP protocols and how you transition. So we didn't feel that it was unreasonable, quite frankly, and hence that's why the number came out as it did. But certainly we are looking at these comments very carefully, and as well as the other comments that are going to be, that we anticipate would be affecting our Part 11 rules. And I should also mention that that part of what that public notice was about was anticipating, as will be coming up in the next afternoon or in the next set of panels, the whole broadband evolution of alert and warning and the notice of inquiry that's anticipated for alert and warning in the broadband plan. So, I mean, we're looking at this, really, CAP stuff's long-term stuff. Because the potential is so long-term. So I think that's about as much as I can say about the 180-day right now.
And thanks so much. Just to follow on with the issue of the equipment being available, whether or not we have the manufacturing capacity to make devices available to some, numbers kind of, the jury's still out on the number, 27 to 30,000 broadcasters and others who will be purchasing equipment. Wade, could you just speak a little on kind of the process that FEMA is going through with regards to the conformance lab, and what is the capacity for getting devices through for CAP compliance? And I don't know, Greg, after Wade is done, if you could speak to the type certification issue in terms of whether or not that might serve as I wouldn't say an alternative, but whether or not the CAP certification by the lab that FEMA stood up will meet the requirements of FCC in terms of meeting that type certification requirement.
Right now, the lab that we have stood up is really, the plans that they have put out and they are tasked to is test compliance with the IPAWS specification to CAP 1.2. So we are not having them check right now compliance to an EAS to CAP translation, to the implementation guide that we're working the draft with our industry partners on. So that's something that we can work depending on if that's the right place to do that or not, to add that in. Right now, there are some applications for equipment that have come in to begin testing in that lab. That lab is ready to go, has all of our plans and procedures in place. There's a website out there that you can submit an application to. They need to stay in step with the full standard, and there's some hesitation with that standard being finalized by OASIS before I think we'll see products start flowing into that lab. With that said, I'd also like to say that we have seen, to address some of the industry concern and what's the status of vendor support for the standards. At NAB, we had, I think, 6 vendors that demonstrated CAP to EAS translation. Minor slight differences that we work out through the implementation guide that we intend to adopt with the standard when we get to that piece. But the response and some of those folks that brought boxes to that demonstration really, no thanks to us, responded and turned around and built boxes that could do that in a week. So I think that there is quite a bit of capability in the manufacturing and in the product market out there that potentially support this in a very quick manner.
And just to do that follow-up, what I hadn't mentioned in response to your prior question is that CAP is out there. I mean, there are a number of states that have CAP-based alert and warning systems right now. And so we are being educated by them in terms of what we think are reasonable transition times. In terms of any kind of certification, this is something that we're looking at, but I'm not familiar with any current requirements. There's certainly no Part 64 EAS. We've never subjected the encoder decoders to Part 64. They've got the emissions requirements. Is any box that does?
No, I'm sorry,
No,
no.
no, they don't, do they?
Yes.
What?
They're required to be typed up, it's under Part 11.
Yeah.
They have to, encoders have to be certified. They have to apply for and get certified under Part 11.
And
It's,
so we're
Part
anticipating.
2 rules.
Well, we'll be anticipating. I think we're just going to have to talk about that.
Yeah. I don't know if there are any manufacturers.
Because, I mean,
who
that's
can talk
certainly
about that.
part of the transition to CAP, is that how would you change the certification program, but the extent to which your test lab, which is a great website, by the way.
So let me just enumerate, and I'm sorry, so I see this as 2 different issues. So right now, Part 11 says if you make an EAS encoder, you need to be certified.
Yes.
So this CAP translation device takes in CAP, it decodes CAP and encodes SAME, or the EAS protocol. So I guess the issue is, do those Part 11 rules apply to that? And does that device have to be evaluated by the Commission for its correctness of being creating a protocol? And that's the, it's a question. There are people who allege, no, you don't. And there are people who go, well, I'm not entirely sure. I think what's important is that we don't get far down the path and go, you know what? Everybody who makes a CAP EAS translation device or does something or makes a new product has to resubmit that product. And so, history is replete with folks jumping out and building something, well, it's really selling a product before a standard is finalized, and it's in the same boat that you guys are in. It's like we're waiting for OASIS to go, yep, we're done. Because things get changed at the last minute. And I'll tell you, history is replete with a product getting out of market, and then when the standard is published, some small thing changed. So it is really important that you adopt the standard. You can't do that till they're finished. And even though I'm fairly sure that every manufacturer has designed a product, they are not going to go, this is it, until you go, this is it. So the fact that they can design and build a product in a week is one thing. Manufacturing enough to get them to every EAS participant and installed and tested in 6 months is an entirely different thing altogether. And if any of you are airplane movie fans, you know what to do. No? Okay, never mind.
Let me raise, good points, very good points. These are things that we've all raised in our mind, but bring up an anecdote of type acceptance, or whatever that proper term is, for the NDEC. There was a manufacturer who had something in his NDEC at the time it was approved, and that could not be removed. It was superfluous. But in order to sell his product, he had to leave that card inside the NDEC, even though it had no function whatsoever. And it raises the question that since there's no specificity to having an approval for the CAP protocol once it's adopted, anyone that has that as in a one-box system where you have your NDEC and your CAP decoder all part of that box, it begs the question whether you can build a box anticipating CAP 1.2, and maybe it goes to 1.3 before it's published, as to whether they can change it from 1.2 to 1.3 in that NDEC without having to go back through a recertification process. So,
Yeah.
Again, good questions.
Yep. I think all that are going to require a little bit further discussion when it comes to the type certification issue. We have about 15 minutes remaining in this panel, and I certainly wanted to open it up to questions from those who have joined us here today, as well as to receive tweets that are coming in over the net. But one of the other hot topics of the day, aside from CAP and other developments that are taking place within the alert and warning community, is the national exercise that's being planned for 2011, which the FCC issued a notice of further proposed rulemaking a little bit earlier this year. And so Wade, I hate to keep picking on Wade, but I'm sure certainly to make it around to the rest of the panelists here when it comes to the national exercise. If you could provide maybe a brief summary of FEMA's plans for the national exercise, and maybe just a brief recap of the exercise that took place in Alaska in January of this year, along with the event code issue that surfaced in Alaska, and maybe provide some clarification on that.
Mm-hmm. Yes, so to start in Alaska, our intent, and I think it was a huge plus of really the Alaska test, was to, I guess in August it was the first that we sat down and talked with our FCC partners and our White House partners, and they said, we need to test this system. And we said, let's exercise the system and not test it to begin with. And then we said, before we roll this out in a national perspective, where can we check and learn about what we're going to need to do this on a national scale? And we chose Alaska because it's geographically separated, so that we could test there without affecting the rest of the nation. Alaska also has a very well-trained or very well mature emergency management association in conducting live tests of their alerting system. They do an annual tsunami alert as well as an annual AMBER exercise of their systems up there. And they also have a very well-trained public that's used to and understands exercises versus real alerts. But What that offered us was a place to go check our procedures, to really learn and develop more of our partnership with everybody we needed to work with in this, FCC being a key to that, the broadcast associations being another huge key and lesson that we learned in Alaska, as well as us understanding the magnitude of the outreach that's going to need to be required to do this on a national scale. And so I think our priorities and our planning pieces at this stage are really to firm up and more mature our partnerships with our broadcast partners, our FCC partners, and then we need to include in that outreach our state and local governments, the folks who are the people who control and manage alerts across our nation, because every incident is local first. And so that outreach effort to the state and local government authorities, with the broadcast industry, to the broadcast industry, and then to the public is going to be a huge piece of our initial plan. Speaking to some other issues that we did, I don't want to call them issues, but things we learned in Alaska, we did verify, I'd say, or validate an issue that with the way encoder-decoders were developed in the 95 to 97 period, with the way that the message what message format should come out, how should that message be addressed. We learned a great deal with the cable industry and the primary type of encoder-decoders that are used throughout the cable industry in the nation. We learned about our procedures at FEMA and how there are pieces that we need to work on and correct. And we also learned about the reliability of the the audio relay system that is in place, and the way states do relay that national EAN code. We have work to do, but I think we have a list of things that we need to work on, and the community's ready to assist with that.
Good, fantastic. And on the issue of origination and event codes, the comment was made that there was a wrong message sent out. But I think there were some workarounds that were put in place to try and accommodate the implementation of event and origination code and the encoders and decoders, the various encoders and encoders and decoders that are currently out there being used. And so I think that was more of a workaround to ensure that everyone could participate in the exercise in Alaska. But we did discover, as Wade mentioned, that there was some procedural issues across the entire landscape, not only at the federal level, but within both at the state level and with some of the broadcast community as well. And so that raises a good issue. I mean, I think basically validates the training and ensuring that the procedures that are used to actually issue an EAN are well documented and understood. Steve?
Yeah, it's my understanding that the EAN was issued, and EAN was also used as the originator code, and the problem was that the decoders looked at that and said, well, that's not on my list of valid originator codes, so it's an invalid message, and threw it out. And appreciate, I think FEMA and FCC both have been very willing to work with us and been very cooperative, and they've heard our questions and our comments and react to them, and we really appreciate that cooperation, and I'm sure it will continue.
Thanks. Brian?
Yeah, I just want to comment on separate but related, I think a different flavor of what Wade shared and the discussion on the national testing. But Antoine, to your question earlier about testing of CMAS kind of in the development stage, I'd also like to note that the rules for CMAS once deployed contemplate a required routine monthly test for those national carriers that serve, around 90% of the nation. These are the equivalent of national tests. And so this would be monthly testing from the federally administered alert gateway through the commercial mobile service providers infrastructure, It's using, a test group so that we're not bothering, people with, on their handsets with these monthly tests. But it would also include regular testing from the C gateway interface to ensure that the Federal Alert Gateway communicates properly as it's supposed to with the commercial service gateway. So just another point I think worth adding on the testing front.
And that's good. I mean, to just follow on, Brian, the first national test certainly is going to be focused primarily on legacy EAS. But in going forward and looking at other components that will comprise kind of the IPAWS umbrella or suite of capabilities for delivering alert and warnings to the nation, certainly the intent is to make other components of IPAWS available or to bring those into the test process as we evolve that into more of a comprehensive testing regime going forward. And so it'd be CMAS as part of the national test, and GTAS and the ability to target specific communities of folks where there may be some type of event occurring, or other technologies and distribution networks that will come online in the future. But Mark, from your perspective, I mean, we've talked nationally. The NOAA has been very supportive and engaged in the exercise in Alaska, and then moving forward with the national exercise later in 2011. Are there any concerns, based on the kind of huge distribution network that NOAA has with regards to conducting a national exercise and NOAA's preparedness?
Well, let me first start off it's important that we do have the national EAS test. I mean, certainly we've talked about it for years, and even as part of the national exercise plan and our national level exercises we hold as a community, if you will, we need to get that stressed out. We need to test it out. We need to find out where the hiccups are and where things don't work. So from a NOAA perspective, we have a Dr. Jekyll, Mr. Hyde at times, is that we originate the messages and also we're a user of it. So as oftentimes where we're creating, as Wade mentioned, the annual tsunami alert, and we coordinate with everyone on that perspective, we learn as we go along the coordination. And we believe as the user, the local community, the state and locals, we look at them almost as an appendage of ourselves, so that if we don't work with them through our warning coordinating meteorologists at our 122 forecast offices, that's where we look at that partnership and relationship. So did they get the message? Did they not get the message? What failed? And we're constantly looking at that from alerts and warnings, and the feedback we get from the broadcasters, the cable industry, CTIA, IP addressable devices are, I didn't get the message because. And we need to gather that information. I think we learned that, many lessons learned, of course, in the Alaska test, of it didn't get there, and why didn't it get there. So oftentimes we believe that we have the nut cracked, and we believe that we've solved all the problems until we get to this national level exercise, and we get to these national level tests where we find out in rural communities, oftentimes, that infrastructure that we believed was there may not be exactly as we had it laid out on the wiring diagram once upon a time, maybe a few years back. So we look at this as a partnership and working with the industry and, of course, the federal partners to solve those problems and identify them before we get to the national test, and hopefully we'll minimize those, but realizing that the more we do this, the better it will be.
Good, fantastic.
And I'd just like to add to that, in the rulemaking, it was unanimous across the board interest in conducting the national test. Everybody in this community agrees it's the right thing to do, as Mark pointed out, and that we will do it. The issues are, well, how, and in terms of that, some of the big ones really come to outreach. Outreach and reporting are the two that I'll discuss right now, because if you're going to try to have a test that's going to involve 30,000 participants who are ranging over a wide spectrum of manufacturers and what they monitor and how they monitor it, and then you also are involved with the cable, it becomes an extremely complicated process. And to be able to, so we're really thrilled with the response to NAB and the response.
It's really 300 million plus participants.
You just made it that much harder then. And when we have a terrific team here at the FCC working on it, and an inter-bureau team, and when I tried to, some of them who had never heard of EAS, I tried to give them an idea of how it worked. I got a video of the World Championship domino drop, that just the one leads to a, but it worked. You see, they got it to work, and I think we can get it to work, that even though you would have one might not work and then another 100 after that wouldn't work, in this case they got them to work. So it was just a question of getting through to these folks, figuring out ways to getting them through to us, working through their state organizations, working through our organizations to determine what the issues are, because just as much as we are testing the public's response to this, we're also testing basic connectivity, and I see that as it's a very simple challenge, but it's multiplied thousands of times. And so that, in their outreach, and the other big issue, of course, that we've gotten, which we're looking at right now, is the whole idea of pre-test testing, whether it's manufacturer test beds or cable test beds, doing some kind of pre-analysis so that we can take as many of the variables out of the picture as possible once we pull the switch.
Good. Thanks, Greg. And we certainly wanted to provide the opportunity for folks in attendance to provide a couple of questions if you have any. We have about 5 minutes or so, so we would ask that we keep the dissertations short and get to the point on the questions, and see if our panelists might be able to address those. Harold Price.
Good morning. Harold Price from Sage Learning Systems. My question was going to be, was there in fact going to be a formal way of doing this pre-test? My concern about a national test for EAS in 2011, we learned some things in Alaska. We haven't yet assimilated those, consolidated them, and implemented them. Done the outreach to the users, let them know what changes they need to make in their equipment to actually do this. So I can't stress enough the importance of a pre-test. Otherwise, a national test will simply relearn what we already know. We now need to take action on that. There was another accidental EAN in a Midwest state a couple of weeks ago. We found out something different there as well. It's very important now, knowing the kind of things we can learn, to do that pre-test, to find out what else we can learn in a small environment, get them fixed before the national test with all the attendant public outreach that needs done on that. The other issue is the 180-day clock. And as a manufacturer, let me say this. Unless we start, no manufacturer is going to build 30,000 of these things, put them in a warehouse, hope for the best. We're not going to build any until we get some orders. We're not going to get some orders until the clock starts. And the example I give is, if you take a look, the FCC made a request for comments on, among other things, a 180-day clock. The comment period expired on April 17th. 97% of the replies came in the afternoon of the 17th. That's an example. If you start the clock, no matter how long it runs, the majority of the broadcasters are going to not take action until the very last time. So if you have a 2-year clock, we're still going to end up building them all in the last month. So there are a lot of problems that can be solved by extending that clock a little bit, but don't think it's a manufacturing capacity problem that's going to be solved by extending that clock. It's just going to make it that much harder to wait 3 years and then still build them all in the last month. That's my only comment there. Thanks.
Thank you, Harold. We'll take one more, and then we're going to have to wrap it up, seeing as though we're getting close to the end of our time period here.
Thank you. Thank you very much for allowing the question. Sure. My name is Rob Sklans. I'm the Chief Public Information Officer for the Middlesex County in New Jersey, Office of Emergency Management. It's a pleasure to see Hank here, sort of representing the emergency management community. I think this was a very interesting conversation from a technical standpoint. It's wonderful to see the cooperation. I think Wade made a very interesting comment in that all emergencies are local. And from a rulemaking and policy perspective, while it is interesting that alerts at a national level are mandatory, I hope as we move to additional standards, involve new players such as the cellular telephone community, that we consider the county level, the local emergency management professionals, as they, in a very frustrated way, are trying to get out emergency messages. And because of the voluntary nature, the cooperation, from broadcasters, from the cable industry. We would hope that as we look towards new standards, ease of compliance, that there be a focus on making things easier for local emergency management professionals to get out a warning, such as a shelter-in-place warning or other sorts of things, and not be told by broadcasters, well, I don't want to air that message because I think it'll scare people. And so are we going to be left to negotiate on an individual medium-by-medium basis to get out important, urgent emergency alerts, or will there be more of a sense of that cooperation moving forward and have, in a consistent way, the ability for local alerts to have the same priority as, or have the same ability to get those alerts out now that cellular telephone companies are coming in? Are we still going to have to do those negotiations, or will there be greater cooperation with the emergency management community? So thank you.
And that's probably a good question to end this panel on, but if someone, Greg, if you wanted to address that in less than 30 seconds, I think our time is up.
First off, in the commercial mobile alert system, as I know Brian would also agree, there are levels of alerts for which you can opt in, which could fit very much into the local alert context. You know, a local shelter, shelter in place, for example. Further, this I think is sort of a sub-element of the governor alert, because the rules do contemplate that that there would be delegates of the governor alert. So I would say that this, to the extent that that's going to be focused, that might be something you would want to file within that rulemaking.
Yeah, and from a, go ahead, Kelly.
I think this is a really important point, and a lot of our local state associations talk about this. And one of the big issues that comes up is that, in fact, sometimes what happens is a very local administration does not issue an EBS, they call a news desk. Mm-hmm. And a lot of, I think, you know, we keep talking about this training and understanding. There never should be a negotiation. You know, I think if people sort of stay with the plan and that the plan gets initiated all the way down to a small municipality area, you avoid some of this some of the confusion of who, mm-hmm. you know, who it is, why are you calling, and all those sort of things. So this gets back to training, funding for training, really. You know, you can have technology, but you have to understand how to use it.
Mm-hmm. Good. I think we've run out of time here for this panel. Hank, if you can do 15 seconds.
Very good. In order to try and improve upon the partnership, we actually instituted MOUs now in Maryland for the locals. And it is time consuming, but it gets that partnership started. It is not necessarily started. I wish we had a different answer for it.
Okay. Thanks so much. I want to thank the panel for their participation this morning. I think there's fruitful discussion, and I think, as you can see, this could probably go on for about another hour or two because there are a myriad of issues and things that folks are really interested in and that need to be discussed. And so we look forward to the opportunity going forward and working with both the states, locals, our federal partners, as well as our private sector partners and working through some of these issues. So again, thank you so much for your participation and taking time out of your schedules to be here this morning. Okay, so we're now going to take a 15-minute break. You may go out and refresh yourself, but please be back in your seats at 11:05. Okay, thank you.
please? Hello? Hello? Hi, could everybody take their seats, please?
We're still trying to catch up with
Going to be getting started in just a second, a very short second. Yeah, I said that already. I'd like to start our second panel now. And let me just begin. First of all, I'm Jeff Goldthorpe. I'm Chief of the Communication Systems Analysis Division here at the Commission, and I'll be moderating the second panel. Before I introduce the panelists, let me just say a few remarks to introduce the panel and the topic today. Emergency alerting has evolved quite a bit over the years, and you heard a lot about that in the first panel. But still, even with CMAS, even with changes to the emergency alerting system, we are using devices that are very similar to what we've used over the years. We've now added cell phones in the last couple of years, or we will be adding those soon. But the truth of the matter is that the emergency distribution platforms are a lot like legacy communication systems years ago, before the emergence of the Internet protocol and before the broadband revolution. So think about years ago in public switch telephone networks, when new services were deployed on those networks, it was a major big deal, a major big deal. I mean, it wasn't like you could introduce a new service and not think about the ramifications all the way down the stack. You had to think about all the technologies all the way down to distribution, whether you're going out on twisted pair, on wireless, whatever the case may be. There's no decoupling between distribution and application development, and that's the revolution that broadband and IP enabled. Now, IP is sort of like, from a networking perspective, it's middleware. It's the harmonizer or the equalizer. It's the glue that allows glue's the wrong term to use here. It's what allows distribution to be decoupled from application development. So one of the questions that we'll pursue, just one, but maybe one of the more sort of far-reaching one, is it too soon, or is it inconceivable to be thinking about an API for applications, or not for applications, but for alerting? Just like now the Internet has enabled sort of open applications developments on networks. So those are the kinds of topics that we'll be talking today. When we think about next generation alerting, we'll be thinking about talking about a number of other things too, including what exactly is next generation alerting. It's kind of a generic term. What are the implementation issues associated with it, and those sorts of things. I mean, now before I introduce the panel, let me just say that there's a reason why we're asking these questions, and we'd like to get some expert opinion. The National Broadband Plan dug into these issues and recommended that the Commission start a proceeding, an NOAA that we've talked about before on the panel, that would ask these very same kinds of questions. What does the emergence of broadband distribution platforms or networking platforms, what does that do to emergency alerting? What are the ramifications? What advantages are there? How can you leverage broadband to improve the richness of delivery of alerts and how they're experienced by end users? Those questions will be asked in this NOI, and we're hoping that this panel can help educate us on these topics. So I've had a chance to talk on conference call and now today in person with our panelists. I've asked everybody for opening remarks today to just limit them to very, very brief, who I am, where I work, and very briefly what I do. And I've tried to, well, I've gone on a little bit about what the panel's about, but I'll ask you please to go through the panel and do that, and then we'll come back and start the discussion. Art?
Well, my name is Art Botterell. I've been working on this project that we now know as IPAWS for about a decade with, the development of the Common Alerting Protocol and related activities. Full bios in the handout for anybody who really cares. Currently, I'm employed as a technical expert by the Joint Interoperability Test Command of the Defense Information Systems Agency in support of the FEMA IPAWS office. So I have to acknowledge and thank them for their support, while at the same time pointing out that I'm just an advisor. I'm not in a management role, so nothing I say here today should be construed as a policy either from FEMA or from DoD.
Thanks, Art. Brian?
I'm Brian Daly. I'm the Director for Core and Government Regulatory Standards within AT&T. In addition to looking at standards for evolving the networks of the future, I've been involved in emergency alerting since pre-WARN Act days, looking at how to best deliver alerts over cellular networks. Was involved in the Commercial Mobile Alert Service Advisory Committee, where I led the Communication Technology Group. And since the completion of those recommendations, I've been involved in the industry standards effort, the partnership that was mentioned in the first panel between government and industry working on the standardization program for the commercial mobile alert system, and also involved in the development internally in rolling out a product. Looking forward to participating on this panel and sharing some insights on where we're going in the next generation.
Thanks, Brian. Darrell?
Hi, I'm Darrell Ernst. I'm sort of the lemon in the pie. I'm not in the warning business. I was an engineer with the MITRE Corporation for many years, 20 years up until March, and I became deeply involved with the emergency management community in the alerting world after some technology that I had led the development on there. And as a consequence, I got deeply involved in the foundation of the Partnership for Public Warning, and then subsequent to that, after helping get CAP started with Art, and my involvement was minimal there, I then started looking at the warning problem from the system of systems engineering point of view. And right now, I'm primarily involved in the testing of fighter aircraft and missiles. So it's a completely different world. But thanks,
Well,
Art, for bringing me back here.
Well, Darrell, I'll tell you what, that's important that there be some alerts where those are going, right? So let's not leave that out.
Okay.
Thank you. Dennis?
Hi, my name's Dennis Gusty. I'm the Deputy Branch Chief for the Office of Interoperability and Compatibility at DHS Science and Technology Directorate. Part of my portfolio is to work on the requirements gathering for standards, EDXL to be exact, the Emergency Data Exchange Language. And we gather the requirements and submit those through OASIS, which is the standards development organization. I'm also supporting FEMA with IPAWS and CMAS. It was mentioned earlier, Section 604 of the WARN Act spells out that Science and Technology Directorate will stand up a research, development, testing, and evaluation office related to CMAS. So that's the area that I'm working in.
Thank you, Dennis. Claude?
Hi, my name is Claude Stout. I'm the Executive Director with Telecommunications for the Deaf and Hard of Hearing. My organization, TDI, focuses on providing leadership to ensure equal access in telecommunications, media, and information technology for people who are deaf, hard of hearing, late deafened, or deafblind. TDI has been around for 42 years. We have had collaboration with many other consumer groups over those years, and we work especially in the emergency communications area, and we want to ensure that deaf and hard of hearing individuals get the information. In the past, it hasn't always happened. So whether we're at home, whether we're in the workplace, we want to get the same information. Today, our lives are just not always at home and at work. However, we're everywhere, and we are out there. There's not always a physical workplace anymore, so to speak. So we function just like the rest of you. We're on the go. So whether we're shopping, whether we're at an event, whether we're at the doctor's office, or whether I'm in my car, we want to have access to emergency information. So I look forward to a continued dialogue with you guys on that this morning. Thanks.
Thank you, Claude. Mike?
Good morning. My name is Mike Naraki, Director of Wireline Standards in Verizon's technology organization. I have responsibility for standards, strategy, and requirements for all of our fixed network standards, including things like video delivery networks, internet standards, and emergency notification. Obviously, emergency notification is a very important aspect of our Fios TV platform. Thank you.
Okay, Mike. Thank you, Mike. Fran?
Good morning. I'm Fran Trentley. I'm a Senior Director with Akamai Technologies. Akamai Technologies runs an overlay, global overlay on the internet. We serve 25% of the global web traffic, so you use us every day, whether you're shopping online or watching live streams. We make the internet a reliable place to conduct business and mission-critical applications. My responsibility is to support my 100-plus U.S. government customers with their public-facing applications.
All right. Thank you, Fran. Please join me now in introducing the panel. Welcome. Now, here's how I thought we would do things today. What I've done is put together a set of questions. I've talked with the panel about them, shared with them, so there's no surprises, and not too many anyway, maybe one or two. And we're probably not going to get through all these, but we'll get through some of them, and at least one, and then we'll see where it goes. And I'm open to letting things go wherever they go, and we'll just, when a topic dies out, we'll start a new one. But there's three, or at least two, broad areas I thought that would be worth exploring with all of you today. One is there's sort of this existential question or definitional question of when we say next generation alerting, what do we mean? I mean, one thing that I think of is okay, there's a transition to broadband networks and distribution. We now have sort of a middleware platform that includes CAP and IPAWS. Not sure exactly what all this means at the front end, from the origination end, but I would like to talk about what do we mean when we say next generation alerting. First of all, from an end user perspective, if you're an end user, and all kinds of end users, whether it be somebody with special needs, whether it be somebody that maybe does not speak English as a first language, what does it mean in terms of the features and functions that would be available to the user? And I'd like to start with Art. Do you have any thoughts on that? And then we'll just go from there.
Oh dear. My immediate thought, thank you, Jeff. My immediate thought was kind of high level, which is, to a certain extent, the question becomes, what do we actually mean by alerting? I think next generation alerting just means the continuing process of applying new tools to the general problem of alerting. So what is that general problem? The Partnership for Public Warning decided that we simply weren't going to go down the rat hole of trying to define what a warning was. In my own practice, I've developed a working formulation for all of public information that splits it into, for all of emergency public information, that splits it into three aspects, of which alerting is one. There's alerting, informing, and reassuring. So you have the air mnemonic. And alerting is, in my mind, largely a matter of what is also sometimes called attention management. So it is not providing a bulk of information so much as it is redirecting people's attention from whatever they were focused on at a particular time to something that is salient that they didn't know about. So to some extent, I think in the previous panel, somebody referred to the bell ringing function. That's a good example of it. the telephone bell rings, that gets our attention, then we go pick up the phone and we get the information. Now, no act of communication is only alerting or only informing or only reassuring. Just as an alert can be the sort of the binary message of a siren, either it's sounding or not, to the relatively very rich 90 characters envisioned for CMAS, to the somewhat constrained message that we can now deliver over the emergency alert system, to the much richer sort of presentations that are going to be possible under CAP. So that's one of the sort of the variables between media, is how much information can come with that first alert. But the real point is that people only have it said that people only have so many snaps in their synapses, right? We only have so much attention that we can pay. We budget that. And an alert is a communications act aimed at redirecting people's attention. And any technology that we can use to achieve that end, I think it falls under this very broad rubric of next generation alerting.
So if I take that, if I take your point, right, then I'll follow it and say that if there is a limit to how much information people can absorb in a classic alert, then is next generation alerting really expanding the number of distribution platforms so that alerts can be made available on more devices, or is it increasing the amount of information or the richness of the information or the texture of the information in a way that the alerts are more useful, or is it both?
Oh yes,
or,
definitely.
Okay.
Definitely yes. If you look at the social science, and we've got quite a lot of it, and hopefully Darryl can talk about this a bit more. One of the things we learn is that people hardly ever act on a single warning message. It requires corroboration, and they get that through multiple media, and they also get that through the process that Dennis Milletti calls milling, where they talk to each other, which becomes very important when we start getting into the social media aspects of this. So we want to be able to do a full court press with this urgent information, and that means delivering it into a lot of form factors. So there's a technological argument for this sort of integration and diversity, which is that no single technology is going to reach absolutely everybody all the time. But there's also a human factors argument, that people need that corroboration for them to get past the what the researchers call the normalcy bias, and the rest of us call denial.
Does anybody else have anything to add?
Yeah, I'd like to add to what Art commented on, and it was brought up in the first panel. We Science and Technology sponsored that workshop with the National Academy of Sciences 2 months ago, and one of the things we did learn was, as Art pointed out, that people do look. They'll receive the initial alert from a particular device, but they'll always seek secondary and third sources of information, and typically it's the traditional radio and television networks that they turn to for that additional information. So Jeff, to answer your question, it is both in terms of next generation. It's a combination of what we know today and what we are looking at for the future.
Okay. Darryl?
I think that we need to go further in the way we define alerting. For many, many years, the purpose of alerting has been to give people a warning so that they can take appropriate action, but they figure out what that action is. We now have the means to take it down to the more personal level, to serve, as Dennis Milletti called it, the publics, not the public, but the publics. We have one represented here with the deaf and hard of hearing, but there are hundreds of publics out there that need serving. So alerting evolves to become a management tool, and it has to have the richness of information, but it also has to become personal. Today, when you get warning of a tornado, you don't know whether you're really on the target list or not, but we have the ability right now today to give personal information to people about where that is. And it would further evolve to where there is feedback from the users. It has to be managed. You have to do the systems engineering. But the ability for special needs people to be able to alert back to the warning center, the 911 center, wherever is appropriate, to say, I need help. I'm stranded, I'm bound, or I can't get out, or whatever it is that's needed. So alert has to evolve from becoming put your head between your knees, you know, and kiss your ankles goodbye, to what do I do? And then the other factor that has to be taken into account is that I think still the percentage of people that get their warning information is through the social network, not through the media. There may be more current studies. Herb may know more about that than I do, because National Weather Service has been working it. But for a long time, the social scientists have known that about half the people don't get their information from the primary warning systems. And so social networking from our network people here becomes extremely important in reducing the number of people at risk.
Okay.
Jeff, I had a comment.
Good.
This is Claude. I agree with what everyone has said actually so far on the panel. I think it's also important to make sure the alerting message is sent out in more than one format, including in alternative formats. So, for example, a video format or a text format or a graphics form or something of the sort. Sometimes alerts go out and they don't really say anything. Often on television or even on your internet screen, you will see tornadoes. But for me, as a deaf individual, I say, okay, there's a tornado somewhere in my viewing area. Where? And what do I do? Do I stay here? Am I supposed to go somewhere else? Or where's the tornado moving to? That kind of stuff. So, again, if there were different forms of the message sent out, for example, in video, it could go out in sign language. If it's a text form, whatever. Just make sure there's a teeny bit of information attached to that message so that there's something there for the person to get. And also, if there are graphics, make sure they're clear and that they're supported by text, not just graphics by themselves, which don't carry all of the information.
Do you want to say something, Brian?
Yeah, I agree with all the comments so far. When we look at alerting, the content really needs to be targeted, relevant, verifiable, and actionable. I think those are the main characteristics that we looked at with CMAS, and I think they would apply to alerts of any type. As we move forward into next generation technologies, we should look at improving the text context of alerts by putting together more meaningful event information. Look at multi-languages, which was an issue we discussed under the Commercial Mobile Alert Service Advisory Committee. We also need to support different types of media capabilities being distributed down. But we need to take caution there on what types. We can be overwhelmed with information if we're not very careful on how we define that. And we also need to make sure we enhance the message updating and cancellation features so that when information changes, we can get that information out to the citizens in a timely manner. We can update them with the latest information or cancel it if they're no longer in danger. I think all of that's important. And I'm going to go back to this bell ringer analogy that was mentioned. I think in the broadband report there was a specific example of a pastor in American Samoa during the 2009 8.1 earthquake who the emergency alert systems worked, but he took it on himself to ring the church bells, which got the information out even broader to those that didn't have readily access. And I look at the next generation emergency alerting as being an extension of those church bells, putting it on devices that users will have with them every day, whether it be their cell phone, whether it be when they're connected to the internet or other devices.
Okay. Jeff, I wonder if I could reframe, well, at least my answer, and maybe the question a tiny bit, by saying what is the value of next generation alerting? What are we trying to achieve other than just keeping up with the technology? And it occurs to me that very much of it, and this is what I'm sort of a synthesis, I hope, of what I've been hearing, has to do with relevance. Again, if you look at the social science, the so-called cry wolf phenomenon is actually a bit of a misnomer because people have actually a surprisingly high tolerance for false alarms. I frequently, is Mark Paese still here? Because I frequently say that explains the continued existence of the National Weather Service. And no, that's in, okay, Herb, okay, he's heard me say that before. And I mean, that's unfair, but it's true. Nobody expects absolute perfection, and I think this is sometimes a standing high jump that we ourselves put ourselves up to. But what does cause people to become desensitized is when they are bombarded with irrelevant alerts. So it's a subtle difference. And relevance turns out then to be the real goal of public warning, you know. And relevance occurs in a couple of dimensions. Two of them are, first off, presentation. Claude has spoken about presentations that are appropriate to people with hearing impairments. Then you have presentations that are appropriate to people with visual impairments and so forth and so on. Presentations in different languages. Now that we have much richer data coming to broadcast outlets, will we continue to just use the old red bar crawl, or would that tornado message be better if it were augmented with a map? I mean, there are all these possibilities at the presentation layer that make the message more relevant. The other is geographic targeting, and this is probably the low-hanging fruit. And it's one where the broadcast industry in particular is at a bit of a disadvantage because they're still using an analog technology that doesn't give them as great targetability as, for example, telephone notifications. When I was working at Contra Costa County, I could target down to a couple of blocks, and I didn't have to disturb anybody else. And there were several things a week that we wanted to get the attention of a couple of people in a couple of blocks. If you have to interrupt an entire metropolitan market in order to do that, that creates a disincentive to use the system. And as we migrate toward digital broadcasting, there may be opportunities even for the broadcasters to mitigate that. But certainly we can lower that threshold by integrating broadcast with weather radio and cell phones and all these other technologies in order to give us more options to maximize the relevance and to minimize the imposition of irrelevant alerts, because that's really where the information overload problem arrives. And we're getting a lot, and that's maybe the next genest bit of all of this, is that we're getting technologies that allow us to be much more relevant in our alerting activity.
Mm-hmm. What is it? I mean, let me ask the folks that implement the distribution side of this, and then we're going to turn to origination. But what is it now about the technologies that are coming to market or have already come to market that enables, presumably, since this is what we're talking about, greater personalization, greater relevance? It's not like relevance and personalization weren't important before. I think and it's not like the alerts that we've come to know and love are irrelevant. It's just that they can become more relevant, and they can be, they could have greater applicability if they would reach a larger community of folks that need to hear them or see them. So what is it about the technologies that are coming to market now that make that possible? Mike?
Jeff, I think there's 2 points. First of all, as a service provider of a whole suite of broadband services, TV, internet, voice, the one aspect is really the integration. It's not the services unto themselves. It's really the integration of services by the end user. So I think when we talk about alerting, it's next generation alerting from an end user perspective. It's really the ability to integrate traditional means of distributing broadband alerts with some of these new capabilities, social networking, internet delivery, video streaming, perhaps content delivery networks. All these things come into play. I think the second point is we're seeing basically the end user taking control in many ways, and I think that applies to broadband alerting as well. So to the extent that either through regulation or simply the end user affecting their own experience, to the extent that end users then can control the manner in which they receive emergency alerts, I think there would be benefits through things like language or the ability to receive video, text, audio messages, those type of aspects.
Mm-hmm. Brian?
Going back to Art's comment, targeting the alert is going to be very critical to make it relevant to the people that are in that impacted area. And I think, some of the comments we've heard back from CMAS where we're targeted to the county level, that was a first-generation compromise because there were so many different systems that had to be supported under the first-generation CMAS. Some of the operators will target down below county level in the initial phases, but as we evolve to different broadband technologies and learn different capabilities that are available, the targeting will get down just to that population that is going to be impacted an immediate threat. And I think that's one important factor. You also talked about the emergency notification systems, or auto dialers as I'll refer to them. Targeting down at the block level is good, but I'm thinking back of the California wildfire situation in San Diego County, where in a 15-minute period they tried to dial out to a significant number of users. Well, networks aren't engineered to handle that type of traffic all at once, and 90% of those calls were blocked. We need to look at, as we move and evolve into next generation alerting, how can we look at systems that are ineffective, like SMS-based, like emergency notification systems? How can we look at technologies that could replace those into a more efficient, and as Admiral Barnett said in his opening comments, timely distribution of messages, and not have these delays or blockages or prevent other users to get onto the networks?
Okay, thanks, Brian. Yeah, that issue of impact on network architecture and design is something we're going to return to a little bit later. But let me, Fran, social networking has come up a couple of times now as sort of a game changer in terms of not only user control of alerting, but just a whole new way for maybe this phenomena that people have talked about already of the bell ringing phenomenon. Now, now we have social networking apps that can ring the bell. So go ahead.
So we see examples of that now, where specific links or information we posted to social networking sites, it becomes very viral. The interesting piece on responding to that is we can tune the response due to what we sense from the request. So there's a lot, especially if it's web-based, and that's what I'll kind of focus on. If it's coming through the web, we can see a lot of things about you, your location, your language settings, your language accept settings, what language you want the response back, and we can, whether on your mobile device or a well-connected device, and we can tune the response back to the end user and his location and his device, and be very specific with that. The distribution that you mentioned, we've seen millions of emails out to millions. We've seen tens of millions of responses within hours to these kinds of viral distributions of national messaging. So, I mean, I don't think it's a challenge on scale on the website now. We've seen it. How many people have watched the BP live stream? Right, that's an incredible amount of people. I can tell you how many. It's tens and tens and tens of millions.
Verizon would get me a broadband out where I live.
Right. So you bring up a great point, and that's adaptive streaming, right? So we can also see the type of the type of bandwidth that you have available to you, whether it's a small mobile device or whether you're well connected and sitting on Verizon's infrastructure, and you can take a meg live feed, a high def feed, or meg or better, or you can only get 300 kilobits, and we can tailor that depending on what you're connected with. So interesting. We've seen it both. So there are examples out there.
Mm-hmm. Okay, so you see that, obviously you see that having a major role, right?
Absolutely. It has a role now.
Yeah. Okay. We'll talk more a little bit later about sort of the implementation issues that come up in connection with delivery of next generation alerts to end users. But let's talk the other end of the architecture now, from a alert originator point of view. It almost seems changes happen. I'll say it. I mean, I'll assert. Do changes happen slower there? Is it harder? Is that a harder end of the problem to work? How adaptable are alert originators to changes like this? What kinds of changes would be required, and how much desire is there for the kind of change that that broadband distribution implies? Go ahead, Darryl.
Okay. I have studied part of that from the systems engineering standpoint. If you go back to who you're talking about, the preponderance of alerts in our alerting system today comes from National Weather Service. I think it's 90-some% of all EAS messages. Okay. Those people you can get to, and they'll respond to the users. They are open to adding different alert types and things like that. But you subtract them out. They're on a daily basis. And you go back to what all of us have been taught, all emergencies are local. It's the people at the local level using the alerting system who need to be considered and addressed, because when the hurricane comes, Katrina comes, or the earthquake comes, or the tsunami comes, it's the local emergency managers who have this urgent need to get information out to those people. And so if you go to them and start addressing their needs and looking at the training requirements that were mentioned in the previous panel, it's a challenge, and that can be addressed. It's not just the technology, it's the training, but the technology can facilitate the training too. You take all those issues into effect. But from a technical standpoint, there are other issues. One of them that has bugged me because I had to address it in my technology was message management. If you take, in today's system, if you issue an alert, you're an emergency manager, and you issue an alert, you lose ownership of that message as soon as it's entered into the system. An example, I was in the EOC out at Loudoun County during the hurricane a couple of years ago. I was supporting the ops manager on EOC. There had been a contamination of the Fairfax water system. Loudoun County, certain parts of it have a contract to get service from there. So the first thing that the Med Desk did was issue a boiled water alert, all right? Then the water system was shut off. So they had to bring in water trucks, which are hard to get. You have to have contracts. It's only certain kinds of trucks. We were able to get 2 to serve the entire Loudoun County area. They then found out that the problem was isolated to one small area of the community. But in the meantime, CNN had picked it up. And CNN started putting a crawler on there for this boiled water alert. Now, if you go into a home, when you tell people there's an emergency, and a hurricane's a perfect example, what do they watch? You go into most EOCs and you look on the broad screen display, what do you see? You see CNN. You don't see the video feeds of the local situations. Our alerting officer, who's the public information officer, tried and tried and tried to get CNN to take that down, and they told him to go take a hike. And in the meantime, it was creating this overload on the emergency operations people. There were mayors calling in from towns because citizens were complaining to them, demanding water trucks, and they didn't need it. All they had to do was turn on their water because their water wasn't affected. And yet, we couldn't get CNN to turn it down. As soon as Loudoun County EOC issued the boiled water alert, they lost ownership of the message. Now, CAP provides a way of updating messages, killing messages, and all that stuff. But once it gets into the EAS or NOAA weather radio system, broadcast picks it up and it's gone. And I think that's one tiny little technical issue that needs to be addressed. And it's not only technical, but it may be regulatory too.
Mm-hmm. And I mean, in fairness, I think, the broadcasters have the technology that they have. Yeah. And it is mass
absolutely.
Media. I mean, we are now in a transition from a mass media era to a new media era, which means localized and personalized and a lot of things. The broadcasters are broadcasting, but it does have side effects.
Well, how does maybe this is a stupid question, but it seems like an obvious one. I mean, as we transition to CAP-based alerts, even for the broadcast community, which was talked about on the last panel, does that change your opinion? Does that change the game?
I think Art touched on it. We're in a transition phase. It provides the ability to use the features of CAP. But if you look at the way it's picked up right now by the media, they pick up only the information at boil water in Loudoun County, okay? And that's it. And it's done, and it's not an automated system. It's somebody sitting there selectively putting into the crawls on the national media what is newsworthy, okay? There are a lot more messages going out than just that. There was messages going out where the shelters were and things like that. It wasn't getting picked up by national. It was on our local media, but it wasn't picked up on national. So they're picking up, and you've got to understand their situation too. They need to provide the coverage, and they do provide a valuable service in keeping it up there in the public's eye. But when there's erroneous information, there needs to be a way to, because it has consequences. Erroneous information in the warning system has consequences.
So that's, you know, to the extent that next generation alerting systems can help to at least improve or deal with that, then
Right.
that's something that should be, that's a point that should be made in the work that's ahead of us.
All right, maybe there's a way of when the message is withdrawn from the originator, is that it propagates through the system and it provides a warning to the media to withdraw that particular message or something like
And
that.
just to quibble, see, this was an example where the message was not so much erroneous as it was merely over-distributed and therefore irrelevant to a lot of people who didn't know.
800,000 people.
Exactly,
And it applied to Fairfax.
Right, so I
But
mean.
that was a
right.
separate message.
So again, this is that relevance issue, and as we get more location-aware and location-based technologies, location is only one dimension of relevance, but it's kind of the low-hanging fruit right now because so much of the technology that we're getting has, you know, that capability. We can really cut down on that sort of message spill.
Right.
You know?
Okay.
But I think there are a couple of other things I wanted to point out about what emergency managers at the local level, I think, want. I mean, we've already said that, you know, effective warning is corroborated warning, so they want to use all the tools. At the same time, they don't need any more work, particularly this is not a shirt sleeves environment typically when you're doing these warnings. You're doing it under stress and with a lot of people, you know, asking you to do a lot of things. So they want it to be simple, integrated, a single procedure, if possible, to issue warnings rather than having to go through a checklist to do EAS and then a separate one for CMAS and then a separate procedure for sounding the sirens and yet another one for the telephone notification system, which sounds insane, but that's actually the practical reality right now. So there's the benefit of integration is it actually shrinks, you know, I call it a write it once approach. It simply shrinks the workload. That's something that emergency managers want very badly. That also guarantees consistency in the message among various messages. I think we've all been something where we've rewritten and rewritten and rewritten, and by the fourth iteration it's drifted significantly. You know, it's like a game of telephone. So having that one master authoritative message from which all presentations are derived simplifies things a great deal. We talked about precise geographic targeting, but there's another thing, and this is almost an on the other hand, because this is a new requirement that is coming to emergency managers and to those of us who want to support them. The increasing availability of warning, the increasing interoperability of warning, our increasing scientific capability to generate meaningful warnings. One of the things this does is this creates a lot of conflicts with jurisdictional boundaries because natural hazards don't care about where the county line is. And so you begin to have issues of reciprocity and mutual aid that have really not arisen before. And so what emergency managers also need is a standard of practice for warning. Right now, it's frequently much easier to come up with a rationale for not issuing a warning than it is to take the career risk of issuing a warning that could be a career-limiting move when you have no top cover, you have no policy framework. This really ties back to the training issue. It goes to what are we going to train people on? If you're a paramedic or in this country, before they ever put you on a fire truck, you've been carefully schooled as to what you can do and what you can't do. And as long as you hew to what they call their standard of care, you're on pretty safe ground. So you're not going to be sued or lose your house or anything. Warning official doesn't have that currently. And as the policy for warning becomes less and less constrained by particular delivery systems. Historically, almost all of EAS procedure has had to do with the technology of EAS and its requirements. Well, now we have this sort of platonic ideal of a warning in the form of a CAP message, which is deliberately agnostic to delivery systems, right? So now we have the blank slate. What then should an emergency manager do? Right? We need to have that standard of practice, right? Particularly when my activity in County A is necessarily going to affect people in County B. In order for there to be any reciprocity between their emergency managers and ours, we need a common standard. That hasn't really been a problem historically. And this is a case where, change tends to propagate up the stack from technology to procedure to human factors and ultimately to organization. So we have technology standards and they're changing things. And one of the changes that's driving is that now we're having to look on up the stack toward policy and procedure. Okay. So I think that one thing that emergency managers are really concerned about is that it be kept simple and that it be explained to them and not simply dropped on them and said, here's a gun with which you can shoot yourself in the foot, which I'm afraid is the way a lot of them tend to perceive new warning technologies when they're delivered without proper policy groundwork.
Okay, thanks, Art. Go ahead, Brian.
Just do a quick follow-up on what Art mentioned about keeping it simple. One of the challenges I think the alert originator is going to have is as we evolve to new broadband technologies is there's going to be devices out there with many different capabilities. Okay. And how are the alert originators going to know what that alert is targeted for?
Why wouldn't CAP be the middleware that makes all of that invisible to the originator?
Hopefully it will. Right. Or an alert aggregation gateway function as we have in CMAS, which takes that out of the alert originator's end. Alerts, there'll be CMAS 1.0 out there for a long time. There'll be new LTE-based CMAS systems evolving. There's EAS, there's cable-based systems. The alert initiator shouldn't have to keep track of where that alert is going, in my view. All they should do is specify, here's the alert, here's the information, and here's the area. And then somewhere in the system, that gets translated into the appropriate distribution mechanisms.
So, whether, certain fields are not filled out, the aggregator or whatever system is interpreting the alert would make a decision that that alert was intended only for distribution over CMAS, for example, if you know what I'm saying? So that there'd be a way for a system to determine where the alert should go based on what the originator was able to put in, based on what the originator knew.
Mm-hmm. Certainly, you can use the fields within the CAP to construct the appropriate alerts for the appropriate distribution mechanisms.
Mm-hmm. And this, I want to stress, this is a very real-world problem. Something that I think it's important to bear in mind is that CAP is not a new thing. There's been talk about CAP being adopted, but CAP has been in use in a number of places since like 2003. So we actually have some experience with the use of CAP. Now there's been refinements of the standard and again, because the threshold for the 180 days was FEMA adopting CAP, that phrase I think required, acquired is the word I'm looking for. Acquired maybe more significant or more importance than it really deserved. But we've got a legacy, and one of the legacy things that we've seen is that emergency managers, when they're first presented with a CAP input screen, what they want to know is, well, where do I check off to sound the sirens? And where do I check off to send the cellular alerts? Because that's the way they're accustomed. They're accustomed to mapping directly to the individual technologies. So there is a training step where you have to explain to them, there's a level of abstraction here. There's policies, but they're built into the system. You don't have to know where the sirens are located and whether there's a siren in that area or not. You don't have to know all that stuff because that happens automatically. It works really well, but they're absolutely, again, if it's not explained up front, there's a tendency to feel, oh, I'm losing control and to create resistance. When actually it's a level of control that, they didn't actually want, because it drags them down into technical details that they're not usually typically interested in. But it can be a source of real anxiety and resistance if it's not handled through training
Dennis,
upfront.
Dennis, do you have any comments on that?
I'm going to go back to your first question about the next generation EAS, and I think to some degree, it's more of next generation, or I'm sorry, your question, next generation alerts and warnings. It's more of a next generation EAS, I think. If you look at the current version of EAS, it has its limitations. If you look at what some of the local governments and even some of the state governments are doing, I think they're way ahead of the current version of EAS. So the real question is, how does the next generation of EAS work together with these state and local systems? I think when you look at it from that angle, it opens up a whole can of worms. I think going back to Art's last comment about, I'm sitting there in a local office and I have my screen in front of me, my local system. How does that interact with the bigger EAS? And I think, when you talk about CAP, that's the glue I think is going to hold that together. But when we talk about, when we start looking at broadband, that opens a whole new area of capabilities. And I think that's really going to catch on in certain local areas more than it will maybe at the federal level. And rightfully so, because we keep talking about all the incidents. They start at the local level and they work their way up. Mm-hmm. So it only makes sense that the local jurisdictions, if they can afford to, they're going to implement those systems a lot sooner, a lot quicker than I think we will at the federal level.
Maybe let me just toss something out and tell me if I'm saying something different than what you're saying. I sort of equate this problem to the problem we have with NG 911, with Next Generation 911. Because with Next Generation 911, you've got users that are way ahead of the alert aggregation and processing, not the alert, I'm sorry, the 911 call aggregation and processing point, the PSAP, in a sense, right? So you've got users with every kind of device and technology you can imagine. Every time the network rolls out a new technology, there are devices there to use it. It's much more difficult for PSAPs, for a lot of reasons, to adapt quickly. Alert EOCs are in a kind of a similar space. It's just a different, it's alerting instead of emergency calling. And so I just have this idea in my mind that it's going to be hard and maybe slow, and there's going to be, of course, a lot of training involved to move the for alert originators to move into next generation alerting. They'll probably move, and they will move slower than the people that will be receiving the alerts. In 911, the people sending 911 calls are making them from you name it.
Mm-hmm.
Right.
Absolutely. We talk about social networking. If you look at it from a first responder perspective, all of a sudden a citizen now becomes a first responder. Why? Because they have the gadget. They're at the scene first. They're starting to send a message. One example that came up during the workshop 2 months ago was that one of the emergency managers in San Diego was just swamped with messages coming in from the public about the wildfires. So he had to sift through thousands of those messages. In the meantime, before he could even get his message out, his alert, the public already knew about it. So there's I think there's a huge gap, I think, between technology and the folks that are actually using it in the EOCs, for example. So in some regard, it may complicate things more for the emergency manager.
Yeah, I think it has for PSAP, call centers. Daryl?
I think we're going at it upside down. We're asking how the users out there in the field will use the new technologies. How will they interface with the next generation EAS? EAS is a federal government directed system downwards. Yet if you go back to first principles, your first two your second and third question, I guess it was, is looking at it from the standpoint of the user and the originator. Both of those are down at the bottom. They're at ground zero. And so it behooves you to go to that level and develop the requirements based on all the elements, human factors, the human response, the manager's workloads, et cetera, et cetera. And out of that derive the system level requirements that are needed. And then you can tell the EAS, Next Generation EAS Program Office, I assume an extension IPAWS, I don't know, what's needed in your system to make this work. And in the broadband, you can get to what I discussed with you in that email exchange. It was, in the broadband, is the partnering between federal regulators and the industry people to make sure that the next generation, or the broadband for everybody, can support the requirements. Not that the requirements have to be adapted to whatever is provided through the evolution.
Can we pursue that point just a little bit?
I guess in just a second, but I want to, there's something I just want to question, because you have a situation, right, where, and maybe this is where policy comes in, but you have a situation where you've got technology on the let's just talk about alerting. The user, and when I say users, and I know what you mean, you've got users on both ends, right, and that's true. And when I say users, I mean, when I'm using it right now, I mean recipients of alerts, right, who now have the means to receive and render alerts that are far richer. That now you've got user communities that, because of limitations of the technology, had no hope of really getting alerts that maybe they could make good use of, right? And now the technology is able to deliver those alerts to them. And then the other user community, the originator community. So how do you, so there's this, how do you, now that you have this, you've enabled it on the one end, how do you create the desire on both ends? Aside from the fact that there's going to be a desire to sort of an abstract desire, is there a, it's different, there's market driving here, there's sort of abstraction here.
I would submit to you that we were beginning to get a handle on that in PPW. We had some fantastic workshops up at Emmitsburg in which representatives from all those communities, both the special needs people, the emergency managers, and industry, by the way. We had fire chiefs, we had Metropolitan Washington Council of Governments, NWCOG, and representatives from all over. And we had our federal partners there. National Weather Service was there providing corrections on misunderstandings about how things worked, et cetera, et cetera. And we homed in on fundamental requirements. And there's no doubt, in my mind, and I think Art's mind also, that following that process, we could have taken the national plan and converted it into a project plan and eventually into a program. IPAWS is a good start, but I hope IPAWS is something it's always looking to the future. I'm hoping that it doesn't have a goal architecture. The concept of goal architecture is archaic. A goal architecture says you're going to get to this point and stop, and we can't, because these guys aren't going to stop developing the technology,
right.
You know? So IPAWS has to be a starting point, and it has to continue on.
Jeff?
Yes.
This is Claude. I appreciate everyone's concerns and how to put together the right message, because obviously that's an issue with CMAS, and however, once all of you guys settle on what the issue will be, that will be distributed. I think that also you need to worry about where the message does go and who it goes to. I think that I've heard before that before emergencies occurs, there are, whether they're city managers, county managers, fire chiefs, police chiefs, and so forth, who what we call do a needs assessment, so to speak, where they go out into their communities and figure out what technology is being used by the hearing folks in their communities, the deaf folks in their communities, the people who use wheelchairs, the people who are blind, et cetera, et cetera, et cetera, of everyone, to get a pulse, so to speak, for what's being used in the community, and then what general system would work best to meet those needs, whether it's the media, broadcasters, TV broadcasters, the radio, social networks, as we were explaining before, and so forth, to get whatever emergency out there, whatever message you originally, you officially decide out. I'm concerned necessarily with the networks involved, because even last week here, the FCC's chairman, Julius Janikowski, said that in the future, it will not be easy to use the spectrum that we have left. You know, our spectrum is very limited, and for example, to make room on the spectrum for, what was it, the 4G, and now the new iPhone is what I'm trying to say, the iPhone 4, they actually had to, the FCC was having to be flexible in its policies to open up additional spectrum. I think it was 3 or 4 times more was needed. However, the demand for us as consumers is going up, right? We require 30 times and 40 times, according to what the chairman said, more spectrum. So it's not, don't only be concerned about sending the right type of message, but also just sending it to as many people as possible, knowing that they do use different technologies, and really, really, really make sure that no one is losing out in this whole process. Every one of us wants to be able to take care of ourselves when there's an emergency. We want to know how to react. We want to know how to recover from it and how to move on. So just on a basic level, I know a lot of the talking needs to happen on the local level, as well as with the government officials and with industry, and the state level as well, and the national level. Honestly, I see a need for, whether it's CTIA, NAB, who else, NCTA, et cetera, radio associations and so forth, to just be talking with each other to figure out how CAP, CMAS, et cetera, IP protocols will work to benefit every single individual, not only people with disabilities. However, for us, over the years, we're really tired of playing catch-up, because that's what we do. And we also get second-hand information generally. We want to finally be able to get the first-hand information that all of you guys get and respond as quickly as all of you guys can. Thanks.
And you know, in the Partnership for Public Warning, which was a nonprofit organization that formed a month after 9/11 and hung on into, what, about 2004? 5, yeah. Well, when it became clear that that we weren't getting any traction here in downtown Washington, we had a number of representatives of special needs audiences, and those conversations were exactly the sort of thing that we were doing. We were putting together the industry people, the academics, the interest group people, the emergency management practitioners, and I think that's, I think what we're saying here is that that's work that very much needs to be picked up. I wanted to challenge one little sort of, assumption that we have gone with, because it's rhetorical and it's commonly used, and it's mostly true, but occasionally it isn't, and that's this line that all emergencies are local. If all emergencies were local, there probably wouldn't be a whole lot of federal interest in public warning at all, except perhaps if the federal government wanted to get into sort of the interstate commerce, standard setting activity. There's actually a growing class of emergencies that are sort of born federal. The BP oil spill being an example, right? That didn't start in a local jurisdiction. Oil spills generally, right, are actually being born typically under the immediate jurisdiction of the Coast Guard. I dealt with this a great deal in Contra Costa County, where we would get calls from the Coast Guard asking us to sound the sirens on shore because of something that had been dropped in the water. So there's a whole, not just terrorism, but there are a number of different jurisdictions that get involved. At the same time, going to your question of adoption, I don't think that getting adoption by the emergency managers, I don't think that's a problem. Honestly, it's such a non-problem that we actually have a cap legacy problem now, which is that we have a number of states and jurisdictions that already have cap-based integrated public warning systems that are somehow going to have to be brought into the mainstream whenever we define what the mainstream is. So I think that the market demand for integration, for simplicity, for economy is there. I do think that there's been, a lot of people who have sort of been sitting and waiting to see what exactly the federal program is going to be and how much or little they're required to do before they act. But I think there's evidence that emergency managers are ready to go.
All right, good. I'm going to shift gears a little bit now. We haven't talked too much about implementation, and one implementation question that occurs to me is that we're talking now about the distribution of maybe a lot of alerts, or certainly alerts of a different variety over broadband platforms. What does that do when you talk about, say, multicast or broadcast distribution of alerts, whether it's over a social networking medium or whether it's over a more traditional, wireless service, broadcast service, whatever the case may be? What does that do in terms of network architecture and design? How do you plan for that as an operator? Mike?
I'd like to approach your question from just a bit more of a conceptual response. I think the big incremental in terms of going from traditional alert systems to what we might call next generation. With traditional systems over radio and TV, one of the factors is that there's much less dependence on what's happening in terms of traffic load around that event. There are obviously a lot of issues, involving infrastructure and compatibility and filtering through information. But the actual, we know inherently that traffic usage goes up dramatically during any type of event. As you move into next generation type implementation, I think in terms of developing solutions and standards and regulations, you need to think kind of beyond just the simple, how do I get a message from the origination point to the aggregation to the, all the way to the end user. I think you need to think in terms of all the other factors that are happening around it, because they will materially affect the timeliness and the reliability of the messages that are delivered. So if we are looking at things like social networking and video streaming applications and so on, there is a much greater dependency on things like traffic load in terms of actually engineering a solution.
Mm-hmm. Brian, do you have anything?
I think you're hitting on one of the key issues. If you look at the wireless data growth within the U.S., Cisco reported some numbers that in 2009, wireless networks carried approximately 17 petabytes of data per month. Now, petabytes may not mean much to you, but when you put it into context, think of the amount of data in the Library of Congress. That's the equivalent of 1,700 Library of Congresses being transmitted across the network per month. And by 2014, the projection is that's going to have a 40-fold increase. So we're seeing this explosion of data across the network. And with that comes, how do we get alerts out in a timely manner when we have this background loads on the network already? And then as Mike mentioned, during emergency situations, people are going to be demanding more data and more data. So the key, as we stressed, for CMAS was a broadcast capability, cell broadcast in the legacy 2G, 3G, and introduced in the LTE technologies. And as we move forward in LTE, there's also a multimedia broadcast multicast system that's available in the toolbox for operators to explore different ways of delivering multimedia content. Those are efficient mechanisms for getting the data out. with all this background noise, having every individual subscriber in an area trying to access the network and get data, IP-enabled devices trying to use the wireless network, it's really going to be a bog and clog on the network. There isn't enough spectrum, as Claude mentioned, to provide the user with the ability to have as much bandwidth as they need at any given moment. It's just physically not possible. So these broadcast capabilities are extremely important as we move forward.
Fran, did you want to add anything?
So, I think that, absolutely agree. And that content, that live stream or that VOD, if we're going to put a VOD or you're going to put whatever the alert media is, has to be pulled into that local network as well. If you're going to try to send 7.5 million people back for a live stream, we had 7.5 million watch the inauguration in 2009. You can't do that from a fixed infrastructure on the web. I mean, there's just not enough bandwidth in a single location. You have to be able to redistribute. Multicast is an example of a way that you would do that into the local network and then serve that end user as close to the edge, as close to his device as possible. And for all web-based content, that's really the way that you'd have to be able to do it. We've seen currently with the BP stream, live stream, if you're looking at doing something like that, we've seen the same thing with large VODs, so, viral pieces of content where they go out through social media and you see millions and millions of people hit it at the same time. It has to be delivered within that local network, or that you're gonna clog up your middle mile pipes as well.
What, at the risk of getting into something, I've gotten into this thing before in one of these workshops, and I'm still alive. So there's an existence proof that survival was possible. But I'll ask. I mean, one of the solutions, you're all sort of implying that there's a congestion problem or a congestion issue and a surge problem, that you run out of surge capacity at a certain point because everybody's wanting access and capacity at once. You're trying to surge through or punch through with an alert to that same community. Is there a role for priority service or priority access, priority distribution of alerts in an IP-based network to enable that sort of feature?
I've dealt with prioritization schemes in communications for emergency management all my working life, and I've never been terribly satisfied with the results. So I don't know, there may be, but then, you get into QoS, and then, who's going to decide what's got, I mean, you look at the conversations we've had around, gets and telecommunications service priority and wireless priority, who gets to choose, who gets what. It gets very complicated, and there may be other strategies. I mean, that's why I'm so happy that Akamai is here, because they probably have more experience than anybody I'm aware of in dealing with these problems of both large baseline loads and large surge loads. And so they are, I think, an existence proof that there are strategies available. Whether prioritization is the best, I'm not sure. It's clear to me that it's not the only one. But I think that one thing that we see here is the deep rationale for reframing all this stuff in terms of broadband. Because, a lot of the problems that we have with circuit switched, telephones and even, current generation cell phone have to do with the fact that there's minimal pooling of resource, right? The capacity of my phone line to my house does not contribute to my neighbors getting the message at all. It's a separate transaction. Well, when we're doing telephone notification, we're using a system for something it was never designed to do. And so the fact that it doesn't do it perfectly is maybe not surprising. But the point is that as we normalize all of this information into the standard IP bits is bits sort of broadband environment, that gives us new opportunities to look for optimization strategies, which may involve prioritization, which I think frequently will involve, edge services and sort of distributed network design. But I mean, I think we have now a reasonably soluble problem. And again, we've seen where the problem has been addressed. Whereas when we're dealing with, like using wireline telephones for alerting systems, we pretty much know for a fact that we're beating our head against a wall. It's never going to work terribly well. It's only, we're doing it because it's the best thing we have right now. So this, I think, is really why it's important to have this conversation in terms of broadband and to have, this conversation in the context of broadband planning. Because broadband, I think, gives us the tools to deal with some of these surge. Even the wireless services, if you look at the evolution toward LTE and WiMAX and these sort of things, increasingly they're going to this, less circuit switched, thank you, more packet switched pooled resource architecture, because it makes good business sense day to day, and it also gives us the best chance of dealing with surges.
And to follow on with Art's comments, when you look at prioritization, it's what are you going to prioritize? Whose communications? The broadband report talks about preserving broadband communications in emergencies. Well, who gets the priority? Is it the hospital communication? Is it the public safety first responders? Or is it the end user that wants to get more information about this tornado warning that was just issued to their area? It's a balancing
Or is it the
act.
tornado warning itself, which presumably has less information than the request for more information? You know what I mean?
Yeah, right. It's a fine balancing act. You'll go through
absolutely.
to figure out which is more which has the higher priority than the other.
But
those
ahead.
tools do exist though within LTE technology, next generation wireless. We are building priority service for multimedia data in there. They're all options to explore as we look at next generation alerting and information preservation of communications during emergencies.
Okay.
Jeff, if I may, I just wanted to give some advice to the individuals developing, maintaining the networks for our broadband connections. During emergencies, when you're in the process of being alerted to an emergency and maybe wanting to get involved in emergency communications, make sure that if it's voice messaging or video transmission or graphic transmission, data transmission, that those broadband connections are dialed down, so to speak, because that will affect, make sure they're not dialed down, excuse me, because that will affect the video that we will get on, for example, our cell phones. We can do peer-to-peer chats right now. We may be using video relay service or video remote interpreting. And the same with an individual who's hard of hearing. You'll see hard of hearing people suffer not being able to hear on their cell phones because the audio quality was degraded as a result of the message being sent. So both the integrity, robustness, so to speak, needs to be maintained so that we truly do get the same information.
There's so many opportunities for unintended consequences that, prioritization in particular is a technological option, but it can be a policy nightmare.
Now, I'm going to close with a question that applies more to sort of social networking as a platform. And then we'll get to questions from the audience and from the folks online. One of the things about opening the alerting process up to a wider community of users, and now I'm not so much talking just about the people that are receiving the alerts, but the viral effect that we've talked about, and it's one thing for there to be a bell ringer, right? And that's if not an authenticated individual, that's somebody that was, who was it? It was somebody that worked at the church, and I can't remember who, that was you. Yeah, so there's only one person in the community that could climb the tower and ring the bell, and presumably there was some trust in that individual. Now we have, social networking applications where everybody's equal, and nobody necessarily knows who anybody else is. So in some ways that diminishes the value of the alerting process because it results in people maybe trusting the alert even less. How do you deal with that problem in social networking as it applies to alerting?
I'm sorry, go ahead.
I was going to go back to what Art had said earlier. It takes a couple of feeds before somebody buys that. Mm-hmm. And if you're You may not be able to validate the individual's information that he's given you, but if he's sending you somewhere else to go pick up information, if you're gonna jump or redirect from that Twitter or that link to an official link, you can validate the official link. So I mean, you may not be able to validate that initial message, but you should be able to validate after you jump.
This is why people look for corroboration. It's not because they're willful or stupid. It's precisely because they understand about noisy information. But I think, and the problem, the short answer is attribution. Right? You have to know who the source actually is, and if you don't know, then you apply a discount. Now that turns out to be a non-trivial problem even within government alerting systems, making sure that a message is attributable and that you don't, as Darrell pointed out, lose control of your own message. There are technologies for doing that, but it's not a trivial issue. But I think that we have to remember that social media were not invented in 2005. The telephone was a social medium. The backyard fence was a social medium. Word of mouth and interpersonal communication, again, what Dennis Milletti, another of our PPW colleagues, calls milling, that process of people talking among themselves and comparing notes and deciding in the aggregate what they think is reality. That's a reality of the warning process today. The fact that it's electronic changes it. In many ways, it may make it easier for us to understand and observe, but it's nothing new.
Right. I was going to say, excuse me, the social networking aspects, the human behavior associated with it, has been well documented by the social scientists since the flood of 1935, the Johnstown flood. There's tremendous body of knowledge out there that would provide us the means to develop all the requirements that we need to address in terms of using the social networking. It's just that the social networking tools have been greatly expanded, but it's still human beings socializing together, and you're not going to change human nature. There's going to be rumors, so you need rumor control. That's where authentication comes in, but people do look for authority. If they see somebody on the television whom they know to be a trusted government official, they'll trust what they say, even if that government official is giving them the wrong information, but it's an authority figure. So what you say is absolutely true. You need to be able to give them the ability to access the authoritative sources of information.
When we set out to design the Common Alerting Protocol, we didn't start from technology. We did that deliberately because the history of warning systems has been start with a technology, how can you apply it to warning? And that's how you build stovepipes. So you get all the. Instead, we said, what is the common ground in a world where the technology is constantly changing? And we decided that the common ground was human nature and social nature. And so we went to the social science research, specifically a report that came out of the National Science and Technology Council, which I think is a creature of the White House. They did a summary in 2000. It became known as the Red Book Report. There was a summary of the social science research. It was one of the points of departure for the PPW effort. Right. It also enumerated what they knew were the essential elements of information for a warning message. Chapter 6. And Chapter 6, expressed in XML, is basically CAP. So we came from the human factors because the technology is constantly going to be changing. If we build the technology, we're just, running ourselves up a creek. Human nature and social interaction is the closest thing to a constant that we've got in this space. And so I think that in all of these things, we need to look at what we know about the human part of the system and build back from there. Right. Because everything else, everything else is obsolete almost by the time it's deployed.
Okay. Thank you. I'm going to close the panel now and ask if we have any questions either from the audience or from online. Yes, sir.
My name is Ben Cobb. I work for Public Technology Institute, which is an association of officials with technology and public safety responsibilities in local governments. And I have a question about how they will interface with IPAWS and CMAS. But first I'd like to share a personal experience with emergency alerting. It happened a number of years ago, but it's still irksome to me today. I sat down to lunch at a cafe here in Washington and was informed that there was a water emergency declared in the district, and so I could not be served. And I hurried home and turned on the radio to find out what was going on. And the radio station did broadcast announcements about the emergency, many announcements, none of which contained any useful information, like what the emergency was it continuing or had it finished, what we were supposed to do. Instead, the broadcasts were self-congratulatory about what a great job the station was doing in covering the water emergency. I was tempted to file a complaint against the licensee with the commission, but I was more interested in whether I could have a glass of water. So my point is that we need corroboration. We need multiple media, not only for technical redundancy, but so that citizens can bypass, if necessary, the official media, the traditional media, who may dilute, if you will, your emergency message for purposes of self-promotion. So my question is about the local governments. In my discussions with the public information officials and communications people in the cities and counties, they don't know about IPAWS and CMAS. They don't know how they will interface with it. With regard to CMAS, they don't understand why or if they will be required to submit their emergency messages to an agency or a machine in Washington, D.C. for some kind of vetting. They like to know what, if anything, they will have to change in their procedures. If this is a voluntary program, how voluntary will it really be? And will they have to make new investments, and what will it cost? What do I tell these people?
Dennis, you want to? I'm sorry, you're as close as we got to that.
Gee, thanks. You know what? It probably wouldn't be fair for me to answer that question. That's more of a question for Antoine, I think, than for S&T. You know, I hate to punt, but.
These are excellent questions. Let us get answers and get back to you. That's how they teach in PIOs.
Okay. Thanks, Art.
That's why you're on the panel.
Yes, sir.
Hi, we talked about visual and hearing impaired. I'm, of course, more on the broadcast side of it. CAP is a box into which many alerting elements can be put. One of the compartments in that box is for multiple languages. Nobody has yet sort of taken responsibility for putting things in that box. How do you view multiple languages as occurring? Who's responsible for providing that multiple language? The radio stations, TV stations are somewhat frightened to open Pandora's box. They don't want to be told, well, it's you. Hire a translator, have them on 24/7 standby, and you provide the translation. Other people would prefer to see the emergency originator provide the language translation because that's where all the information is. That's where they can make sure that the language is correct. Some people assume that technology is sufficient to provide a machine-level language translation. I got to tell you, 86% accuracy is not enough to tell me which direction to run. So talk about how we're going to solve the language problem.
Mm-hmm. Brian?
These are excellent questions.
Brian. Thanks, Art. I'll take it. Okay.
We opened Pandora's box while we were doing CMAS and slammed it shut and ran as quickly as we could because we saw exactly those issues. But on the serious side, we did look at one city, San Francisco, I believe it was, and took a survey of the census data and looked at what 1% of the population, what languages were spoken. We came up with, I believe it was 37 languages, which would require 16 different character sets on mobile devices. There needs to be a policy in place at the national level to define what languages are used, who has to translate them into those languages, and how they would be rendered on the different devices that are out there. You've hit one of the key points that is brought up in multi-languages.
It's even worse than that. Art probably remembers the incident, the experiment in Los Angeles County, where they did the warnings in Spanish, and they took the English and translated it. And one of the translations
was imperfect.
It was imperfect, and in fact, very embarrassing for a number of people because a word was used that meant something that it shouldn't have meant. So you can't just hire translators, and you can't put it on the industry people, you know. It has to be the government authorities that are issuing it, because they're responsible for providing accurate information. It's a hard problem.
Yeah,
You're right about Pandora's box.
This is one of the deep issues, is how good is good enough and who can tell? I can tell you that as a local emergency manager, I would not use a piece of software, a translation service, or any process until I had some sort of certification that it was adequate.
Right.
And nobody knows how to do that. Language seems to be the hardest thing. Other, presentations for other sensory forms are technologically relatively easy, and a lot of times the personalization can be pushed to the edge, even to the individual receiving device. But language, hard one.
I would add that Canada is using CAP, and they're using the info block in CAP to send a message out in English and in French. And we also learned that Israel is implementing a CAP-based system, and their requirement is to send it out in 3 different languages. So it'll be interesting to see how they resolve that problem.
The operational question is, to what extent do you delay release of a message in one language in order to get translations to the other? Right? Who's got the capability, and do you have to hold up?
I also want to, back to your question, I wanted to thank you actually for raising the language issue, the need for multiple languages, specifically for emergency alerts. I think that also in Texas as well as California, there's such a strong population of Hispanics, specifically Hispanic deaf individuals and hard of hearing, who would also benefit from getting alerts in Spanish, specifically in Spanish captioning, Spanish text, etc. So I think I know San Francisco also has such a heavy population of Asian deaf individuals who could benefit from getting the language in either Vietnamese, Japanese, Chinese, etc. So thanks for just raising the issue in general.
Any other questions today? Sir?
Yes. Frank Bell. Now, not every earthquake is the San Andreas fault, which is rather well monitored, but question is response time. Now, among the many different possibilities and things discussed, I haven't heard any mention of this, but considering that Part 11 gets somehow improved in its definition, that's appropriate to digital TV and HD radio, I looked at that and I considered a reasonable estimate for a response time budget would be about 2.5 seconds. Now, that's just from my perspective. I'm just wondering what your thought is on that particular thing for earthquakes and where response time matters.
Earthquakes are a bad scenario because currently they're sort of self-notifying and we don't have tactical warning. So, but the question of what should the latency goal for an alert be, the problem is that particularly when you get into the final, sort of the last mile, the final distribution system, it's going to vary, So I think you can come up with a worst case figure. I believe there's a goal for presidential activation of EAS end-to-end. That's in the range of some minutes. There was, if I recall correctly, in the DHS target capabilities list, early on there were some goals set for percentage of population notified in a time frame, and later that specification was pulled out because I think they discovered it was a little too complicated to try to turn it into one number. But certainly for the purely digital stuff you're talking about, it sounds to me like you're in the right ballpark, but that's going to vary.
Brian and Mike, what do you guys think?
Yeah.
There's a system in place in Japan that they're developing called the Earthquake, Tsunami, and Warning System. The way that works using cell broadcast is there's 2 waves, an S and a P wave that can be monitored through seismographs. The minute the S wave is detected, they send out a cell broadcast message, hopefully before the P wave occurs, and that'll hopefully give some advance warning. We've spoken to some geologists at the University of Washington, and they said the characteristics of earthquakes, for example, in California are different than Japan, and that may not work. But I think this is an area to research further and perhaps expand upon and look at systems such as what Japan is doing as technology evolves and our understanding of earthquakes.
That particular technology, the time of flight technology has been used in the States. We used it in California. It's in use in Mexico City uses it for events that occur over at Acapulco. The thing is, the P wave travels a little faster than the S waves, so the further out you go, the more lead time you have. In a metropolitan area, you might get lead time from one side to the other on the order of 10, 15, 20 seconds. Mexico City, because their fault line is over by Acapulco, they can get several minutes. So yeah, that's a correction on what I said about tactical warning of earthquakes.
Sir.
Thank you. I'm John Lawson. I'm with Convergent Services. I work with public broadcasters and handset makers. First, let me compliment the FCC and FEMA for holding this workshop. This is very helpful. I've been on MISRIC and SIMSAC and now CISRIC, and it's great to see the progress that's being made. I did have a question, though, about this issue of network congestion when an event happens, as we've seen, and the cell network goes down or the wireline network goes down, as in the example of the San Francisco wildfires. We now have mobile DTV. We've got FM radio. We can use mobile DTV to send warnings to cell phones. We can geographically target it. I guess my question primarily to Brian and Mike would be, what are the prospects of one day the carriers and the broadcasters coming together to put mobile DTV receivers and or FM receivers in handsets to really enable a totally ubiquitous emergency alert system?
Yeah, this topic of different capabilities in the devices has come up many times, and there's a lot of challenges with an FM chipset within a device. Probably don't have time to go through that here, I'm sure.
We have about
A minute. Probably can't cover it in a minute. I mean, a lot of those capabilities are really driven by the marketplace and consumer demand for those devices, for those capabilities within the device. There's capabilities inherent into the networks that we can make use of for alerting and getting information out to subscribers and the end users, above and beyond some of the capabilities you've mentioned here. Certainly, it's areas for discussion further. Whether or not that comes to fruition, it's hard to say.
One last question, and we have to make it very quick. Sir?
Hello, good morning. My name is Hisham Kassab. I'm with Mobile Apps LLC. I had a question about how emergency messages arrive at the FEMA aggregator. Is it expected that the alert originators have to actively transmit it by email, FTP, or some other protocol? Or does the FEMA aggregator, is it constantly polling and listening in all, multiple servers that are known to host these messages, and then pull them from them that way? And kind of like a related question, who's responsible for developing the specs for, the communication between the alert originator system and the FEMA aggregator?
Antoine, do you want to take that? You were turning around like you were going to answer it. Yeah.
Response to that. But I was turning around and looking at Mark Lucero, who's the lead for an iPod aggregator within the office. But right now we're working with DHS S&T on standards. And so while in the past we've talked about the C interface specification and other components, the A and B specifications for the aggregator or for iPods in general, now we're talking more about just an iPod specification that is just a set of standards that would allow folks on the origination side to interact with the iPod's aggregator as well as on the dissemination side of the house. And so it will not be, we will not receive alerts and warnings via email. It'll be all an automated exchange based on the standards that have been identified, developed, and then adopted by the program.
But the alert originator has to actively transmit it?
Yes. Yes.
Okay. Thanks, Antoine. Sorry to put you on the spot.
Now that Antoine has spoken for IPAWS, I can say that in other CAP-based systems, what has typically been done is an HTTP post with some authentication on the input side. There are some other systems using some other protocols, XMPP for one, but typically that's it. There's a desktop tool of some sort, or and then it does the authentication handshake, and because the other one, if you do a polling thing, then you've got a lot of inefficiency. Plus, then you have to have a database of every possible source, and it's a lot easier to manage that in the authentication and just hand out credentials than it is to have to say, well, what IP address are you going to be at? So that's how some systems do it. But again, I don't speak for IPAWS on that.
Okay. All right, before I introduce Lisa for closing remarks, let me just thank our panelists and ask our audience to join me in thanking them. And closing the workshop today is Lisa Folks, Deputy Chief of the Public Safety and Homeland Security Bureau. And let me add, while Lisa is making her way up, let me add my thanks to all of you for coming out today.
Thanks, Jeff. I'd like to first of all thank both Antoine and Jeff for the really terrific job that you guys did in moderating both of these panels. I'd like to also, on behalf of Jamie and Damon, thank all of our panelists, both panels, and ask that you please give both panels another round of applause. I hope you've all found this very lively and informative. Also like to thank, on behalf of Jamie, our federal partners, NOAA, Department of Homeland Security, Science and Technology Directorate, the White House Military Office, which some of you may or may not know is another federal partner in the emergency alerting space, and specifically to Eric Pankiff, who is on the working group with the federal working group and essentially leads the federal working group from the National Security Staff on emergency alerting issues. Thanks to the staffs of both the FCC and FEMA for your tireless work on emergency alerting. And finally, and most importantly, I'd like to thank all of you for attending. The sheer number of you here today, and the fact that I think, as Wade mentioned earlier, we have representation from most, if not all, of the segments of the emergency alerting community, speaks volumes as to the importance, how very important this issue is to our nation. We certainly look forward to continuing to work with all of you as we move forward on IPAWS, including Next Generation EAS and CMAS, both the initial CMAS and sometime in the future Next Generation CMAS, hint, hint, Brian. In addition to which, we certainly at the FCC and FEMA also look forward to having further discussions with all of you as we move forward on looking at how we leverage broadband technologies to ensure that all Americans can receive timely and accurate emergency alerts. For those of you who have traveled from outside the D.C. area, I wish you a safe and enjoyable journey home. Thank you for sharing your time with us today.